All right. Are we live? Are we live? Is this live? Awesome. Thank you so much, my producers, my lovely producers. Cameron, I love you, man. Appreciate it for all the support you're giving to this conference. All right, everyone. Welcome to the third day of JDConf, the Microsoft first true Java conference for some speakers who are good at finding old images on the internet. So, we have a great show today for you. If you have not yet had coffee today, I encourage you to do so. I'm having mine here, and I have a special mug. A woman needs a man like a fish needs a bicycle. This is a great mug. My wife loves it, by the way. From Guinness. If you don't know Guinness, we have a special reason for wearing this shirt today. At the end of this day, we're going to have an AMA Ask Me Anything. So please stay tuned for the AMA. We're going to have Martin Verberg all the way from the UK. It will be noon for me, but at the end of the day for him and most of the members of the AMA, of the guests. So we're going to have a beer, most likely. All right. Let me jump to my PowerPoint to walk you through a few bits. Oh, I forgot to scratch the day 2 here, but okay. We are on day 3. Logistics for today are the same as of yesterday. We just have sessions starting at 9 a.m. after the keynotes, and 30-minute session, 5 minutes break. We're gonna chat with the speakers on those 5 minutes. Free water for everyone, as usual. Just go to your kitchen or office space and open the tap. Use a cup if you can. Cookies may be available. If you don't have cookies yet, it's Thursday. You gotta go to the grocery store already. The weekend is coming. You have to have cookies at home. In the nearest bathroom, just go around the corner. In case of fire, I do hope you have a kit. I do have a kit. I think I do. But you know what to do. Get an extinguisher and put the fire off. I don't know. I haven't had fire yet. I don't know how to deal with that. So let's hope there's no fire at anyone's place. Today, we have an amazing keynote section with Mala Gupta from JetBrains. Yesterday, we had Trisha G talking all about the good stuff on modern Java. I mean, she presented it right after Venkat. Venkat didn't use an IDE. He used TextMate full of macros. If you can do what Venkat does, man, good for you. Or you can go with IntelliJ from JetBrains. Thank you so much, folks, for helping with JDConf. Mala Gupta will talk about the Java community and communities in general. Stay tuned for her session on how to be part of one. And Bruno Souza. Bruno is a great friend of mine. We are both Brazilians, although I'm living a little bit far away from Brazil these days. Bruno has a history with Java. He also has been coaching developers around the world how to improve their career, how to be a great developer. So if you want to improve your career, find better technology or find better jobs or find just, maybe joy, if it's that's what you're looking for, Bruno can help you with that for sure. After the keynotes, we're going to have great sessions from our friends in the Java community and some of our own Microsoft engineers. We're going to start with Simon Ritter from Azure System. Simon, if you show what I think you're going to show, that's okay. Dr. Heinz will come and talk about Project Loom. That's it. That's the main, I guess, the main session that so many people are waiting for today. No offense to any other speaker, but Heinz, you definitely know how to attract people. So congratulations, buddy. Reza Rahman will come and share all the investments that Microsoft is doing in the Java EE space and working with our partners at Red Hat, at Oracle, and IBM to bring Java EE into Azure. Next, we're going to have Rich Turner. Rich is a .NET Windows guy. I still love him, and he will talk to you about how to make the most of your productivity on Windows. If you're a Java developer working on Windows, that's the session for you. Next, Jonathan Giles, our own Java architect for the Azure SDKs. Jonathan will talk about how he's been designing APIs for many years, and he's going to share all of his experience. He might show you a little bit of Azure SDK examples, but literally just examples. I don't even know if he will actually show Azure SDK examples. I'm just saying, maybe. We'll hope for. After that, Edson Yanaga from Red Hat. Edson has lots of experience as well as a Java developer, as a Kubernetes developer, as a YAML developer. I don't know. I'm just teasing him. Edson's a great friend as well, and he's going to share all the great stuff with Quarkus, using VS Code and the extensions that Red Hat did for built for VS Code, including one for Quarkus, and deploy that on OpenShift that we have here as a service on Azure. Finally, Deshaun Carter. Deshaun, congratulations on your new job. He went from I think was from VMware to Redis Labs. It's a great transition. If somebody was moving from Redis Labs to VMware, that's also a great transition, as Bruno Souza can probably share during his keynote. It's all about the moment that the person is living in, right? So congratulations to you, buddy. And at the very end, you're going to have an Ask Me Anything. So if you are watching this and you cannot make that session, that's okay. But please drop your questions on Twitter with the hashtag JDConf. Martin Verberg and the Java Engineering Group will be there to answer questions about how Microsoft is contributing to OpenJDK. Why is Microsoft contributing to OpenJDK? And all the other questions that you can think of, just shout to Martin and his team. I'll be there with my friend George, and Kirk Pepperdine will be there as well. We're going to be talking and chatting and just having fun, and hopefully a beer. So please do take this survey if you are working with Spring. We, as you may have heard, we have a service called Azure Spring Cloud. It basically can bring Spring Boot applications and easily deploy on Azure. I think it's a cool service. I think it's an interesting approach. It bundles several open source projects, Netflix something. I'm not an expert in that area, but if you are and you have something to share, check this survey. And if you do, you have the possibility to get $150 gift card. Last but not least, actually not last, we are running the JDConf challenge as part of the Microsoft Learn platform. You can access this and just be part of it and get some nice badges on the online platform. You gotta to learn how to do Java development, how to do cloud development. It's a great way to improve your skills for the new world of cloud. And if you want to learn more stuff, check out this URL. It will take you to the Microsoft Learn platform front page. It will show you all the resources that you have at your hand. All free, nothing you have to pay for, just like this conference. So thank you so much for staying with us for the third day. If this is your first time watching, no worries. The previous days are already recorded and available on demand on YouTube. Just go there on the Microsoft Developer channel and you can find what we had yesterday and on Tuesday. So with that, I would like to invite our first keynote speaker, Mala Gupta. Mala, how are you?
I'm doing good. Thank you so much, Bruno. How are you?
Yeah, I'm doing great. Thank you for joining us. As you can see, it's still morning for me. Where are you based?
I'm based out of New Delhi and it's evening for me. It's 8:45 in the evening now.
Okay. Oh, that's wonderful. I think you just had dinner or you will have dinner. Is that it?
Yes, I'll have my dinner after my session.
Okay, awesome. I hope the food is great, just as my poutine and my maple syrup in the breakfast. Who doesn't have maple syrup and poutine for breakfast, right? Folks from Canada,
Right.
That's the rule, right? So, Mala, I don't want to take much of your time again. Just please get started, and thank you so much for being part of this initiative with the Java community and our Java friends. Thank you.
Thanks a lot for having me. Hi, everyone. Thanks for joining in for this session today. And today I'll talk about the vibrant Java communities beyond the obvious. How communities can help us to reflect on questions like who we are, our values, and how we see ourselves and others. And I'll do that by sharing a lot of my stories, and of course, you can relate them to your stories. So, depending on your experience, you might have a different answer to this question. To me, communities mean friends for life who also understand my code. This picture was taken at Oracle Code One, and I made a lot of new friends on that event. So, my journey with communities at DelhiJug started in 2014 when I was planning to host a session on exception handling in Java 9. That was right after the publication of my first book. I was amazed by the organizers at DelhiJug. So, we have Gurpreet, Vikas, Steve, Jitendra, Chavnish. I was amazed at the amount of time and effort all these people put in organizing the session by a person they did not know about. At that time, I was just curious, why would they do so? But of course, I stayed for the same reasons, for the time and effort that they put in for me, for a person that they did not know. And post that event, I started to appreciate literally everyone for everything that they did, for their time, the efforts, and the energy that they put in. The second instance or story I want to share about is an event that we hosted at Delhi Jug that was in 2017 by Venkat. We had multiple events during the day. The event was amazing. We know Venkat is a great speaker, and everyone was happy. But I was completely baffled by one instance, which was when Venkat started sharing about his failures in the initial phases of his career. I was completely I don't know how to express myself, but to me, my failures should be wrapped and hidden at a place where no one can see them. So how can a person, a public figure, talk about his failures at a public platform in front of so many? What did that teach me, or what did I learn from that instance? I even talked with Venkat about this, and he mentioned that he, not really the sentences, but he has accepted who the person he is. He has accepted his failures, and that taught me to look for achievements or the journey where I should no longer be embarrassed about my failures. And that really has shaped me as a person, because now, if I think that there is something that I'm embarrassed to talk about, then I really need to work on it. So I really look out for things that are still bothering me. And of course, you can do the same. And that can really shape you as a person, because it's only when you reach a certain stage can you talk about your failures. And the time that you can talk about them, you have gotten over them. And of course, that means you are more of a happy and successful person. uh, this one is another life changing event for me. So, I was supposed to speak at the JBCN conference 2018 in Barcelona. I had a connecting flight from Delhi, Istanbul, Barcelona. I had not slept for 2 days when I boarded my flight from Istanbul to Barcelona. And I was asking myself the question, why am I doing this to myself just for a session? I did not have the answer then, but I'm so happy that I did that, because, of course, I get to meet a lot of new people and make new friends. And I would be forever indebted to Jonathan and Nacho, who sponsored my trip to from Delhi to Barcelona so that I could speak at that event. But what that really made me appreciate about myself is that I realized that I was much capable of what I thought about myself. I managed to speak at a country which was, of course, not mine. I was traveling all by myself. If you are a frequent traveler, I don't know, that might not mean a lot to you, but to me, it meant a lot at that time. And the biggest of all is of letting go of my inhibitions, things that I think I might not be able to do or I want to do, but I could do when I give it a try. Yes. Of course, I have always been grateful to the opportunities that I received in life. But after this event, I really, really am more grateful to every opportunity that I get in life from anyone. Of course, as I said, I mentioned that a couple of times that I have been making a new friends in the Java community. When did you last make friends? Was it in high school? Primary school? I don't know, in college? How often do you make friends now when you start working? Because as we grow older, we try to kind of build more walls around ourselves. We become more sophisticated and we don't really let our guards down and be friends with other professionals, people. When you are a part of community, you can actually be yourself and make a lot of new friends, and you make friends for life. And I would be sharing a lot of names with you who I love, I respect. I share things with them and I care for them, and it's vice versa. The people that I would be talking about, they do that with me, and I'm so grateful about all of these. So this is Trisha Ji, and I met her first at the JBCN conference, and I'm very fortunate to work with her every day. So we interact with each other every day. An amazing person to work with, of course, capable, competent, very warm person who really cares about the team. A lot of other people who I don't have any pictures with me because, of course, we're not traveling for the last. For this year. But these are the people I really, really respect because these are the people who have kind of cared about me when I was a nobody. Heather introduced me to Martin when I was really struggling with my website, which was eJava Guru. I was trying to figure out how to get more people to the website or how to help more people, how to reach out to them. And Martin really helped me because I don't know, Martin, how do I share that? But it was a really great gesture for me. Sharat, as we know, oh my God, an amazing person. Brian, Josh, Arun, all of them. They're amazing people to work with. And I've always, I'm so sorry, I'm missing the name. Morris, yes. I've referred to Morris notes on lambdas in Java 8. An amazing person. Amelia, I just love her. A very caring person. Again, a lot of people that I know and I know they love and care and they are part of the community. And so, yes, we have the Java certification ladies here. Um, as I said, a lot of people that I have been able to work with, to communicate with, probably every day or on a regular basis. The fun or the essence about being working with all of them in the community is that I can ping them anytime that I want to, and of course they care to respond and they really care about other people in the community. This is again one of my favorite pictures. So this is from the other community that I'm part of. That's not only Java, but yes, of course, it also includes Java. That's Women Who Code. We had an event in Singapore, and as I said, Friends for Life. I really loved how Amanda was walking on the stage. She has been working in the security services at USA, and I love the swag. Right. What would you do when you have no commands or directions to follow? This is what community gives you, provides you the opportunity with. And this could be intimidating, that could be liberating, um, both ways. So you really have to ask yourself the values that you have and what is it that you have been thinking of doing from probably all your life. And when you get answers to those questions, You can actually move forward and do that in communities, because you don't really have to follow a path. You can chalk your own path. For example, so this is a newsletter that we have at Women Who Code Delhi. So that's a monthly newsletter where I lead the publication and I feature one leading women in tech. The purpose is to share the events that we have at Women Who Code Delhi, and to highlight the achievements and failures. The intent is different. I don't want career to be an option or a choice for women. I want that to be a norm. And I really want everyone to know that. So, uh, the values that I have, things that I've been wanting to do ever since, communities give me an opportunity to do that. So again, this is a panel discussion that we hosted at Women Who Code Delhi, where I got the opportunity to ask the leaders in tech how they are helping women to climb the leadership ladder in the new normal. Again, as I said, communities really help you to do what you want. So this is me at one of the sessions at a college in Delhi. As I said, communities can really bring out the best in you. You understand your strengths and your weaknesses, which is really good, because you could be a leader, you could be a follower, you could be a team player, you might not be a team player. And you understand that when you are working in a community, because as I mentioned, there are no rules to follow, there are no bosses to report to, no managers to report how much you worked on which task. Of course, we don't have that at JetBrains. Yes, we do, but not very strict ones. But still, communities literally let you fly and to be yourself. Of course, you can also understand that you are not a team player, probably, you are more of an individual contributor. Everything of those is okay. You don't have to be kind of feeling low that you are not a leader, you are not a team player, but more of an individual contributor, but that's okay. We all need to kind of understand that it's okay. It's okay to accept and understand who we are and play on our strengths. That would make us more happy. Okay, and I want you to answer this question in the chat window if you can, if you have any modes of communicating with us. What would you do if you don't fear the failures? And this is what we get to do at communities. They are so welcoming, they are so forgiving. What happens, I remember one of the instances, we were planning an event and the things did not turn out as they were supposed to. And it was like, okay, what do we do, what do we do now? And the other person said, it's okay, it's okay. If this doesn't work out, we can go for plan B or C, or just say that, okay, this is not happening. So we can do anything that we want to. And when we don't have the fear of failure, because we have tend to have a lot in our minds that this might fail or that might fail, but again, it's okay. Yes, this is one of my favorites too. When you work with communities, you literally become a leader because you are taking a lot of decisions, you are taking actions, and you are taking the responsibilities of those actions. So this is an event that we did at JetBrains. So that was a 10-hour long event, an online event which we did in July. And I was leading the organization, and I'm so proud I did that. And I got the courage to do that because of accepting who I am, to be okay if I fail. And a lot of the qualities that I polished over my working with the communities. And this is amazing, Trisha, as usual. And we both were hosting this session. Again, be yourself. At communities, we don't have the hierarchies. There is no CEO or no student. You can be yourself and you can talk with the other person the way you want to. That really brings in the best, because you don't have to have lots of layers of abstractions to you, or sophistications, as we call them. And yes, I already talked about this when I was talking about this on the other slide. Of course, you when you meet with so many people, you learn to learn, and that really widens your horizon. You get to know things which you don't know. So that really is. And of course, this is my favorite too. What do you do when you travel to new places? Do you get the phone numbers of people you know, your friends and family who are living there? And this is exactly what I do when I travel for conferences or events. I meet with the people from other communities. I take their phone numbers, I go and meet them. And of course, I also call them when I have an issue or a problem, and they are very, very, very kind to help me out. So, we are talking about not only getting things, it's also the other way around. And you only get things when you are ready to give the same to the others. So, finding friends is good, but you also have to be someone's friend. And so, this is the last one, probably second last point. So, this doesn't come in a day. Everything that I talked about, being a part of the community and the benefits that you have, you really have to first get started. Look out for communities in your area. They are easy to find. They usually, the groups end with JUG, which is the acronym for Java User Group. And then you have to kind of like working with those communities. You have to stay there for some time to start liking it. The third step is to start contributing in any way. You could plan a session, you could talk, you could volunteer, and then comes the last part, which is the growth. Once you stay in a community for some time, that's when the magic happens, and that's when you really, really grow. To me, communities have kind of reinforced my belief in humanities, um, because I truly believe that ever since the societies thrived, every society had one or the other way of giving back to the society. So now in the tech communities, we have this one. And the last point that I want to mention is that when you give your, let's say, 10 minutes of your time, what you get back is probably 100 minutes of benefits. Because this happens a lot of time when I do something good, not really good, which I think I'm doing good. Could be that really depends on the other person, how they perceive it. It really benefits me in one form of the or the other. So I'm not saying do this because it will benefit you. I really believe in karma, and I think this is what we humans are. We when we're living in society, we really need to help each other, love each other, respect each other, and share what we can. So, and just in case, so this is my introduction. So, just in case if you're trying to Google me to find out what I do apart from presenting at conferences like this, you can stop now. I work as a developer advocate for JetBrains. I have written a couple of Java books. I'm also a Java champion. And I work closely with the developer communities like the Delhi Java User Group and Women Who Code Delhi, which I mentioned about. So thank you so much for listening, and I'm so excited to talk about the work that I do and how it has benefited me and could benefit you as well.
Thank you so much. Thank you so much, Mala, for your presentation. We got there is a person on Twitter, um, Jim Goth, and he's been tweeting about this conference since day one. And he said,
Mhm.
"This is a really personal and reflective account of true friends and relationships made in the Java community, enjoying the personalization experiences of these talks." So congratulations. It really touched every person that had a sense before so far in terms of community participation. And I'm sure it will wake up those that hours to like trying to figure out how do I be part of this, how do I become part of it, right? So it was a great presentation. Thank you so much.
Thank you.
I'd like to, it was our pleasure for sure. Let me invite Bruno Souza, our next keynote speaker. Bruno, are you there?
Hey everyone. Hey Mala, that's an awesome presentation. I actually made some notes here in the board while you're speaking, so I can talk about those. I can tie into what I'm gonna say. So that's awesome.
Thank you so much, Bruno.
All right, so we got about 20 to 25 minutes. Bruno, you're gonna talk about career development, and as you said, you got some notes from Mala's keynote. I'm sure community participation, whether it's a public community or a private community, sometimes communities inside companies doesn't necessarily have to be an open source or open community, but just being part of a group of people, of community, a group of people that have similar goals, similar preferences, and share the same passions. I think that's what matters. So what can you say before we let Mala go, and how you're going to plug that in?
So I think you're totally right, Bruno. I think that when you talk about communities, we have so many communities in our lives, right? We have, our company communities, we have, our faith communities, we have our friends communities. I mean, we have so many communities, and I think that when we are able to mix our professional with for personal things, because that's what Mala's talking about, right? Java is a group, for example. It's a mixture of professional things with personal things. Someone told me yesterday, oh, Java was a great thing for in my professional life. And I said, well, Java was a great thing for my personal life, right? Because, both of you, for example, are great friends of mine, you're personal friends, and I've met you guys because of Java, right? So I think that's awesome that we are able to mix those two types of communities.
Awesome. So Mala, thank you so much for your time. Appreciate it.
Thank you.
All right, so Bruno, I'll leave it up to you, man. We'll talk later. See ya. All
right, thanks. So hi, everyone. It's awesome to have you here. I just see Kirk in the chat saying I'm clapping. So I'd like to see, so my objective here is to help you improve your career, right? So tell me in the chat your biggest challenge you're facing right now, because I'm going to answer your questions here today. But I want to, before, while you're thinking about your biggest challenge in your career, so what it is, you want to launch a product, you want to, get a better job, you want to increase your salary. So what is your biggest challenge that you're facing right now? Because one thing I was writing down here where Mala was speaking is that, when you talk about, she mentioned about being a leader, right? And this whole point here is how you can actually be a leader of your career, right? And so, and for me, a lot of times that we talk about being a leader or leadership, we immediately think about a boss, right? So the first thing I want you to understand is that being a leader, it's not being a boss, right? So we don't want, of course, being a boss is someone that has authority. You can tell people what to do, right? But a leader, it's not someone that can tell people to do. I mean, there are bosses, there are also leaders, right? But a leader is someone that inspires people, right? That actually get people to move, right? A leader is not someone that has authority to tell people what to do, but a leader is someone that creates a path and people follow you. That's what a leader is, right? You're leading because there's someone following you, right? And so the most important thing for you to understand about, how can you be a leader of your own career is that leader is not about power, it's about responsibility. I think this is the most important thing, that once you are responsible for something, then you become a leader. That's when you're tracing a path, you say, I'm going to go that direction. And then you take the responsibility of going that direction. And then you go, right? And so once you go in that direction, people are going to say, hey, this guy's going in a good place, so I'm going to follow him. Right. So that's the whole idea. So a leader is someone that takes a responsibility. So once you take responsibility for anything, right? Take responsibility for your project, take responsibility for your life, take responsibility for your code, take responsibility for your commit. Anything you take responsibility for, you are setting yourself up as a leader. So I think this is very, very important, because when you talk about leadership in your career, right? How can we take responsibility on our careers, right? Stop blaming others. That's a very, very important thing. Stop blaming others, because it's so easy. I see this all the time. I see friends of mine saying, oh, you know what? You get my boss. I can't come to the event because my boss doesn't let me go to the event. Or I can't learn new technology because my company doesn't work with this technology. Or I can't do this that I want to do because my company or my boss or my husband or my wife or someone, right? And so then you're putting the responsibility for your career in someone else's hands, right? So when you do this, when you don't take responsibility, then you are the one that suffers. Your career that suffers, right? And not only your career, because if your career suffers, then your family suffers. Then your colleagues suffer. Your company suffers, right? So I think that the first thing that we have to understand, that to be a leader, you got to be a leader for your career first, right? So take responsibility for your career. Stop blaming others. It's not anyone else's fault. It could even be, but some people tell me, but Bruno, what if there's someone that's kind of preventing me? Well, yes, it could be their fault. I'm not saying that they're not doing something wrong. But the thing is, if you don't take responsibility, if all you say, oh, it's their fault, there's nothing I can do, then you're going to be stay put in whatever place you are. So instead of thinking about it's their fault, think about, what can I do? What can I bring to me? What can I do? What actions can I take to change the situation, right? So it's up to you. You can do that, right? And basically, when you talk about responsibility, right, there's two main things that I think you have to think to be very responsible for, right? First of all, is your responsibility to improve your skills, right? Skills, let me tell you a difference. There's developers kind of love to learn, right? We're always talking about learning, right? Developers love to learn. We are aficionados for learning, but it's not about learning, right? It's not learning that's important. What's important are the skills that you have. And the only way for you to get skills is by doing. So you don't get skills by learning. You only get skills by doing. So, Bruno just mentioned, you need an initiative from Microsoft to give you skills for cloud, right? But it doesn't help if you go there, you watch some cool videos, and then you don't do anything. You got to go and do, right? So that's your responsibility. But Bruno, I don't have time. Well, it is your responsibility to figure out how to do things, even when you don't have the time, right? To go to eat lunch and come back 5 minutes earlier so you can do 5 minutes, right? Instead of watching a video or a series, you spend that 30 minutes doing something. It's your responsibility of doing. So you got to improve your skills. And improving your skills, you got to do things. The only way, that's how our brain works. The only way that we get skills is by doing things. Right, that's a biology thing, right? You only learn skills. You only get skills by doing, not by learning. So you got to go do things, right? The other point where you have to take responsibility is of trust. People need to trust you. You need to be a trustworthy person, right? When you say, I'm going to do this, you're going to do it. When you say, I'm not going to do this, I'm not going to do it, right? So being able to say no. Lots of people say this, oh, you got to be able to say no, right? Yes, you have to be able to say no, because your yes should be a yes, right? And your no should be a no, right? So that's you have to build that trust. Trust is something that you build. It's not something that other people assign to you, right? It's not your boss that says, oh, I trust you, or your friend that says, oh, I trust you. Trust something that you build yourself, right? So that's your responsibility to build trust. And so I understand that when you acquire the right skills, you trust yourself more, right? So it's easier for you to show trust, to show confidence when you have these skills, right? So that's why those things are very connected, right? But you have to be a trustworthy person. And one thing I want to tell you is that, that's the best way for you to get awesome jobs, for example, right? Because, for you to get an awesome job, the best way for you to get awesome jobs is when people trust you, I'm going to say something a little bit complicated here, but when people trust you before they know you, when people trust you before they need you, right? When they need you, they're going to call you and not someone else. Think about this for a minute. When someone trusts you before they know you, they're going to call you when they need you and not someone else. This is the best way for you to get the most amazing jobs. When you get a phone call and say, hey, Bruno, do you want to come work for me? Right? Because I trust you already. I know who you are. And I know that you are able to solve my problems. So I want you to come work with me. Then that phone call is given to you and not to someone else. And because it's given to you, what happens? You get the most amazing position, the most amazing jobs, right? So trust, it's very, very important for your career, right? And then what this has to do, and that's why what Mala's talking about, right? When you build a community, people trust you, right? Because they know you. They know what you're doing. It's done in the open. It's transparent, right? So they trust you. And so they call you. As a Java group leader, I get calls every single week. Hey, Bruno, do you know someone that can work for me, right? Is there someone you trust that should be a great person for this project? Do you want to work on our project, Bruno? Right? Because when people trust you, they call you and not someone else, right? And remember, trust is something that you build. It's not something that someone else does for you. It's you build that trust. So how do you build trust, right? You build trust by sharing. This is, for me, it's not the most important software developer skills, right? Sharing, but it's the one that helps you grow more your career. The way to grow your career more is by sharing. Why sharing? Because sharing builds trust, right? When you share your knowledge, what do you share? You share what you know. You share your knowledge. So when you share your knowledge, what happens? People trust you. And you become what we call a trusted advisor, someone that people trust. They know that, I'm going to listen to what this guy is saying because he knows what he's talking about. And the only way for people to know what you know is when you share, right? And there's another thing that there's a philosopher that says is, I think is very cool, is that, you think that you think when you think. But the truth is, you only think when you share. You only think when you explain to other people, when you speak, when you write, that's why you write code, right? Because when you write code, you download your thinking to the code, right? That's when you externalize your thinking, right? That's when you think, right? So that's awesome, right? So you can build that trust yourself. You don't have to wait for anyone. Remember about responsibility? It's your responsibility to build that trust. And how you do this? By sharing. And the other cool thing about sharing is that sharing creates collaboration, right? And collaboration is one of the most important skills that we have as developers, because that's what we do. Software development is done by people, for people, marketed by people, sold by people, used by people. So software development is one of the most people-intensive industries in the market. And collaboration, it's amazingly important because we can't solve the big problems that we are having to solve alone. We got to collaborate. And so sharing builds collaboration, right? And so in collaboration, it's action, co-action, right? Collaboration is we working together to solve problems. And by the way, that is the most important skill of a Java developer, any developer, is solving problems. So collaboration is co-action, right? It's we taking action together to solve problems. So that's like going to the heart of our most important skill, right? So when you talk about being a leader, and I see some questions here, right? So leader knows about capability of the team members in a project. So a leader, I can talk about this, Albert, in a minute, but a leader is not necessarily someone that has a team. Think about this. A boss have a team, right? A leader, a lot of times doesn't have a team. For example, Malo was talking about community leaders or Javi's group leaders, right? She is a community leader. In a community leader, you are not a boss. You don't have a team. You know, you can't tell people, oh, you go do this, because you don't have authority over them, right? You are a leader because you inspire people and you take responsibility for what you're doing. So you say, we're going to do these events, and if you don't help me, I'm going to do it. I'm taking responsibility for that, right? And so that means that, you know, if you don't do it, I'll do it. And then you inspire people to do with you, right? But you're right, Albert, because one of the most important things that a leader has to have, one of the most important skills that a leader has to have is to listen, right? The most important skills of a leader is to listen. You know, you can't inspire people if you don't know what they are facing, if you don't know the problems, if you don't know the difficulties they are having. You can't inspire people if you don't listen. So the most important thing of a leader is take responsibility on listening to other people, right? And that builds trust. Listening to people builds trust, because you understand what they're coming from. You understand what problems they have. You understand everything that's going on, right? So I haven't seen any more questions here. If you have any more questions, we still have a few minutes. Send me your questions about your career. So where do you want to go, right? What skills are you trying to achieve? What is it you want for your career? So we can talk a little bit more about this, right? But I saw here Adrian saying that with their mean board talks about navigation your career, right? So let me tell you this. Let me answer you. I'm not sure it's going to give me all the talks, Adrian, but let me do this. I'm going to give you a gift right now for your career. Okay. So let me, Adrian, for everyone here, let me give a quick gift here. So I just put on the chats right there. Oh, and actually, maybe I need to get the guys here on the backstage to know this too, right? So maybe they can put it on the screen. So I just put on the chat right there a link to a free book that I wrote specifically for you to improve your career. It's the Best Developer Year. It's a book. It's a free book, right? It's completely free that you can get to help you. Oh, thanks very much. So it's right here on the screen, right? It's an awesome book to help you. It's a question book, right? On how you can do activities for your career. So that's if there's no more talks, Adrian, at least we have that, right? So question for YouTube: how to deal with politics during a technical career? So that's an awesome question. And you know what? This has everything to do with taking responsibility, right? Because, you know, dealing with, I understand that there is a lot of politics inside companies, right? There's a lot of politics inside anything that you're doing, actually, right? I mean, politics is everywhere. And so actually what politics is, let's first understand what politics is. Politics is actually negotiation. That's what politics is, right? We're trying to think about politics like a bad thing, right? Oh, it's this thing that I don't want to involve, right? But politics is about negotiation, actually about having a relationship with people and negotiate. Politics is about disagreeing, you know, having to work with people that you don't like, and even working with people you don't like, you are able to collaborate. That's what politics is all about. So it's collaboration, is negotiation. So what is the most important skill that you need to have when we're trying to negotiate, right? When you try to collaborate, is to listen. You have to listen. So instead of you falling into this trap of politics, right? Listen to what problems people are trying to solve, what problems people are dealing with. What is the other person's opinion? What's going on? You have to understand first what's going on, and then you can take action, right? Because then, you know, because that's a mistake I see a lot of times. A lot of people make this mistake of, I just want to go and make action. I just want to go and do things. And, you know, I just want to go and do my job and just work on my code, right? But then I don't listen to people. I don't know what problem is trying to solve. I don't know what my company is trying to solve. I don't know what my company is trying to achieve. I don't know what my boss is trying to achieve, right? This is one of the biggest mistakes that we make as developers, right? We think that all that we have to do is do our technical work, and we don't have to worry about collaboration, right? We don't have to worry about our boss. Look, guys, our job, if you work for a company, even if you're your own boss, right? But our job is to get your boss successful, right? That's our job, right? So if you don't understand what your boss needs, if you don't understand what's the problem your boss have, how can you solve things? So that's how you have to deal with politics. Listen, understand what the problem is, understand what your company wants to get. And that's going to be an awesome way for you to navigate this whole thing, because politics is about negotiation, right? So someone says, you're very welcome, Bruno. Oh, Bruno Borges. That's for Bruno Borges. That's good. It's two Brunos here. That's awesome. So Bruno, I agree with Juarez. That's an awesome event. Thanks for putting this together. Bruno, Kirk, everyone, Cameron here in the backstage. Awesome. Thanks very much for putting this awesome event together. Thanks for inviting me and making all the work for this thing here to work. Awesome. I want to know more about transition to the mid-level to a more senior role, right? Okay. So this is a very, very important, right? So actually, I'm going to be very quick here because I don't have a lot of time. But so Adrian, right? So if you want to transition from mid-level to a more senior role, there's two things I think you need to do. First of all, you need to improve your skills. How do you improve your skills? By doing, right? So you got to go and do things that senior people do, right? That's how you transition. You go do things that senior people do. And what do senior people do, right? They get involved with more complex projects, right? Not very complex. And you say more soft projects that are more complex than the ones you're working right now. But Bruno, I can't work on more complex projects because I'm not senior yet. Well, that's why open source is so awesome. That's why community, like Mala was talking about here, it's so awesome. Why? Because you can get involved in projects done by the community. You can get involved in open source projects. We are here in a Java conference, so you have things like OpenJDK or Spring, right? Two things that Bruno mentioned here. Microsoft has lots of awesome open source projects. Actually, Microsoft has GitHub, right? So there's a lot of open source projects that you can be part of. So you can improve your skills by doing things. Oh, Bruno, but I don't have the time to do. Well, you can do small things like 5 minutes a day. That would be awesome. So that's the first thing. The second thing you need to do to transition to a senior position is build trust. So people trust you to be a senior. And how you do this? By sharing what you know. Senior developers share. So by doing this, I think you're going to be on your way to really, Adrian, to really become more senior. So, okay, so my time is up, right? So how can we convince to our team to follow me if I'm right? Okay, so Bruno, you interrupt me whenever my time is completely up, because I think it is already up. But so how we convince our team? So basically, you don't convince anyone. A leader inspires. It doesn't convince, right? So a leader inspires. So the one thing I can tell you, Albert, is that Pankaj, right? The one thing I can tell you is that download the book I just put you here, The Best Developer Year, because that book has the 4 steps for you to take action. And the same 4 steps that you can take action, you can use those 4 steps to help other people take action. All right? So you do this, Pankaj, and you're going to see a great way to lead people. All right? So, okay, so, I'm not sure if Mala wants to come back, Bruno wants to come back, but that was awesome.
Yeah.
So thanks a lot, Adrian. Hey, Bruno, that's awesome. Thanks a lot,
man.
Opportunity.
No, this was great. Mala, you have the microphone with a line crossing the microphone icon. So I think that means you are not muted anymore. Perfect.
Thank you so much.
All right.
Amazing.
What an amazing. Exactly. Just stole my words, Mala. Well done. I would like to invite our next speaker so we can have a quick chat before he starts. Simon Ritter, where are you?
I'm here.
Oh man, that's so great.
Oh, you were here.
Let me tell everyone here, if you're watching this, take a picture of this moment here, right? Because You're having such amazing people in this picture, right? And so actually you can do this. You can go on your computer and just take a selfie with all of us here together.
I just did it. I did a screen cap because it's easy on Mac.
You can if you have time, you can also Photoshop and just replace one of us. pick me, and put your picture with all these great people. I gotta say, Simon, were you watching Bruno's and Mala's keynote?
I caught the end of Bruno's. I caught the end of Bruno's session, and it's always lovely to see Bruno because he's so full of energy. He really is. It's great to see you again.
He is. I think I would love for you to go back and watch Mala's presentation and then watch the entire presentation from Bruno, because when you put those things together, it's just a recipe for success. That's it. And we saw that on the comments on YouTube. People loved it. And one comment that caught me was like, we need more presentations like these, Mala's and Bruno's, at conferences, at virtual events, at webcasts, and because technical content, there's a ton of it, right? But when it comes to really develop yourself, they're not much. And the material that exists online, they're not exactly part of the culture of IT books. You don't go to IT book section and you find self-learning skills. It's hard to find those things. So thank you so much, both of you. Simon, any question you have for Bruno and Mala?
No, not really. Just like I say, it's really great to see people again.
So Simon, let me ask you a question for you then, right? We're talking here about communities. Both Mala and I did a little bit, but we're talking here about communities. And you have been traveling all over the world building community, right? So how was for you to touch so many people around the world on so many communities?
Oh, I have to say that has been one of the absolute highlights of my career is just the ability to meet so many people around the world and to share experiences of technology and see how people use technology in lots of different places. I mean, thinking specifically about like yourself, I mean, in Brazil, and I remember on some of the trips that I did to Brazil and meeting Daniel in Brasilia. And the work that he was doing with people there in terms of like sign language and using technology and Java for that really sort of was incredible. And there's so many examples like that of the community coming together and using technology in great ways to help people. That's one of the things I just find fantastic about what I've been able to do in my travels. I feel humbled by it.
Yeah, that's so awesome, man. So awesome. And Danielle did actually great work. And you mentioned sign language, right? Mm-hmm. So, I'm doing a lot of things with sign language interpreters, right? So there's two cool things that happen. So first, when Daniel was here, so they created, because sign language is different in every country. So they created this sign language for Java, right? And so the sign language for Java is J, right? Because the J for Java, and then a coffee cup. So it's J, and so that's the sign language for Java, right? And just this past month, the guy that organizes the accessibility track on our events, so he actually gave me a sign. So now I have a sign for sign language, and that is B, Bruno, put like this. Because I don't have hair.
So Bruno, so my sign will be this, but then like this because I have too much hair, right? Is that it?
Right.
This and then boom. Okay. All right. Thank you so much, everyone. Bruno Souza, Mala Gupta. That was an amazing keynote. Appreciate it. This will be available on demand on the Microsoft Developer channel for anyone to watch at any time. So have a wonderful day and rest of week and weekend. Thank you so much, both of you.
Thank you.
Thank you very much. Thank you very much. Good luck, Simon. Thanks, everyone.
Thank you.
All right, Simon, it's your time. It's your show. You're going to be talking about keeping your application secure. Are you talking about JWT and username and password managers? Is that what you're going to talk about?
Nothing to do with that.
Oh, okay. Good. All right. So let's find out. Thanks, man.
Here, let me share my screen. Hang on. Yep, there we go. Is that working? Oh, yeah, I have to select that screen. There we go. Right, now if we go to there, and okay, hopefully you can see my screen. Bruno? Yes? No?
Yes.
Okay.
Yes.
I will assume. Yeah. Okay. Good. I was going to say I will assume you can see my screen there. Right. Good. Well, yes. Good morning. Welcome. The idea behind this session is, as the title suggests, keeping your Java applications secure. My name is Simon Ritter. I'm the Deputy CTO of Azure Systems, and I've been working with Java for, well, quite a long time now, since I started at Sun Microsystems back in February 1996, about the time that JDK 1.0 was released. Now, the whole idea behind this presentation is to talk about the security of the Java runtime. So we're not talking about security in terms of how you write your applications, how you keep the code that you're writing secure and avoiding some of the issues that you might have in terms of preventing people attacking your code. We're talking about the Java runtime itself, the JDK. And so one of the things that we need to understand is that the way that the JDK is being developed, the way that the JDK is being released, and the way that, most importantly, the JDK is being updated has changed. I'm sure everybody already knows about this because it's been around for sort of 3 years now. And we've seen that since JDK 9, we've moved to the idea of a 6-month release cycle. So now we get 2 releases a year. We get March and we get September. And I think we can all agree that this is working very well. We've seen 7 releases in the space of 3 years, which is frankly incredible. But we've seen that the ability to add new features to Java in a controlled way is really working very well. We're seeing many more features come through much more quickly than we ever have done before. And this faster release cycle has also allowed the developers, people like Brian Gertz, people like Mark Reinhold, to introduce this idea of things like modules that are sort of not included as part of the specification, and also preview features, so that we can include a feature, we can play around with it, we can test it, we can see what's going on, and then move it to the product somewhat later on. And that's a really powerful thing to be able to do. So we can make changes before it gets set as part of the standard. So like I say, I think that this whole idea of the release model is working very well. The reason behind this was that the developers wanted to make the development of the JDK itself, OpenJDK, more agile. And we've seen the shift away from the old sort of waterfall model of developing software to agile development is the way that we do things now. And the ability to respond more quickly to changes in requirements, the ability to do more iterative development processes, continuous integration, continuous deployment, all of those types of things is what this is about. So making the OpenJDK as agile as the software you're developing. Now, the way that we do that is by changing some of the ideas behind how new features are included. So we've moved away from having the release driven by the features to having the features only be included if they're ready. And so if a feature isn't quite ready, they don't delay the release, they simply shift the feature to the next release. And again, that seems to be working very well. Now, the important thing is that having a much faster release cycle means that extended support, extended maintenance of releases had to change. And so rather than the old system where Oracle and Sun before them would release updates on a quarterly basis, and they would release them for the current release, plus some overlap for the previous release. And that could be anything from like a year, I think it was about 13 months, all the way up to sort of like 2 years of overlap. That's just not practical when you're doing a 6-month release cycle. What Oracle said then was that they would introduce this idea of long-term support releases. And that way, one release every 3 years would become a long-term extended support release. Now, a very important thing to understand about this is that applies to binary distributions of OpenJDK. It doesn't apply to the OpenJDK projects and the source code itself. So long-term support releases are only about the binary distributions. OpenJDK projects, although obviously they're extended in terms of people continuing to contribute to them, this whole idea of LTS is only about binary distributions. And even that is not defined in any way. Oracle have their way of doing long-term support releases. Amazon have their way of doing it. Adopt OpenJDK have their way of doing it. Azure have their way of doing it. And it's not set in stone as to how that works. To get things started, Oracle decided that JDK 8, because everybody was using it at the time, or almost everybody was using it at the time, they classify that as a long-term support release. And in terms of how long that would be continuing for, they said that the last public update would be January 2019, last year, and that since then, things would change. However, for personal use, if you're sitting at home playing Minecraft, then you can still get updates until the end of 2030. The next long-term support release, as I'm sure everybody here knows, is that JDK 11. And that means that JDK 9, 10, 12, 13, 14, and indeed 15 are what they call feature releases. And that means that they only get updates until the next release from Oracle. Now, very important thing is about updates. So we've talked about long-term support, but what about how we get updates and the availability and so on? Now, as I said, the Oracle JDK has long-term support release versions. So JDK 11, JDK 17, and so on. Most importantly, Oracle changed the license that they use as of JDK 11. Prior to that, they were using the Oracle binary code license. Oracle binary code license said that you could use Java on your laptop, on your desktop, in your data center without charge. The only time that you needed to change the license was if you wanted to use an embedded system or a single purpose machine like a kiosk or a ticket machine. JDK 11 uses the Oracle Technology Network License Agreement, and that has different restrictions in terms of how you can use it. So there are basically 4 situations where you can use the Oracle JDK for free. That's personal use, meaning playing Minecraft at home or personal productivity applications. If you want to use it for development use, you can use it for free. And then the other 2 situations are if it's an Oracle approved product or Oracle Cloud Infrastructure. Other than that, you would require a Java SE subscription in order to get those updates. JDK 8 is a little bit of a strange one because it's sort of half one and half the other. If you've been using JDK 8, then you can continue to use JDK 8 indefinitely for free, but only up to JDK 8 update 202 and earlier. That's the one that came out in January last year. As of April 2019, the update 211, that was released under the same license, the Oracle Technology Network License Agreement, which means you can't deploy that into production without a Java SE subscription. So why is that important? Well, in order to understand that, we need to think a little bit about vulnerabilities. And vulnerabilities are places where software, and that applies to Java, it applies to any other software, exploit to gain action, something you have preventing an application from working in the way that you expect it to work. So how vulnerabilities are classified is based on what we call CVEs and CVSS. CVE, again, I'm sure everybody's kind of heard of this, is the idea of a common vulnerability and exposure. And a CVE basically defines something that can be used to exploit software. So a problem that can be used to gain access to information or to stop an application from working the way you want it to. So denial of service, something like that. You then have a CVSS, and that's a common vulnerability scoring system. So each CVE has a CVSS associated with it. The CVSS is basically broken down into a number of different sort of fields, which have a score as how easy it is to exploit that vulnerability, whether you need physical access to a machine, whether you can do it across a network, all sorts of different things about how that vulnerability can be used. And then we divide that up into various values. So the value that you get from all those different fields gives you a total value that's somewhere between 0.1 and 10. And so we then divide those up and we say, okay, if it's got a score of 0, clearly there's no vulnerability there at all, so that's none. And then based on what value you have beyond that, 0.1 to 3.9 is a low score, 4 to 6.9 is medium, 7 to 8.9 is high, and then 9 to 10 is critical. So those are the ones that really matter. Those are the ones that are going to cause serious problems if people can actually access those. So how important are updates to Java? Well, actually very important. And what I did here was I looked back over the sort of history of the updates all the way back to January of 2017. That was sort of the easiest kind of date to go back to. And I looked at what was the highest CVSS associated with each of those releases, those updates. And what I've done here is I've obviously shown that in terms of the version that was impacted, the date, and the maximum score that we had there. And then I put a line to show you where updates to Oracle JDK 8 stopped. And if you look at that, obviously you'll see that the first update after public update stopped had a CVSS of 9.0. That's a critical vulnerability that affected JDK 8. So if you were running JDK 8 in production, there's a significant vulnerability that could affect your systems. Now, what's interesting about that one is when you dig into the details of it, it's actually only on Windows, and it's as a result of one of the DLLs, the libraries, that are used to build the JDK. So it's not even in the Java code itself. It's in the Windows DLL that's used to build the JDK. And then we can see that since then, we've obviously had a fair number of sort of medium ones. Thankfully, we haven't had any high ones. And in fact, in October, October was quite a light release update. And so there wasn't really anything there. But you can see there's still quite a few in the high scoring range. So it is important to keep your JDK, your platform, up to date if you want to make sure that your applications are as secure as possible. Then I also did another sort of breakdown of this, and I looked at, okay, what's the distribution of CVSS scores across all of the updates? And then this time I went all the way back to January 2015. There's a total of 328 CVEs which have been addressed in updates since then. And as you can see, obviously we've got a small reasonable number of lows, got a reasonable number of highs, a few criticals, and I then broke down criticals into the 10.0s, which are the absolute ones that you must fix because it's too easy to exploit otherwise. And then the vast majority are in the medium range. But there's a significant number in the critical range. What's that? 59 critical vulnerabilities that should be addressed over the last 5 years. Now, one of the other things that's important to understand about the JDK is standards conformance. How do you know that what you're getting in terms of a binary distribution matches what the specification says it should be? And so each Java release that we have is defined by a JSR, Java Specification Request. This is developed through the Java community process, and a JSR consists of 3 parts. Firstly, there's the specification itself, and that defines, in the case of the Java SE platform, exactly what goes into the core Java. What do you need to call something Java? You've got a Java virtual machine specification as to the functionality of how to process bytecodes and so on. Then you've got the Java language specification that gives you the syntax of the language that can be compiled into bytecodes. And you've got the core class libraries that need to be there in order to support the runtime. So that's the specification. The second part of the JSR is a reference implementation. And that's essentially a set of source code that shows that the specification can be implemented. You haven't defined something that's impossible to implement. In the case of Java SE, OpenJDK is the reference implementation of that specification. It's open source, you can look at it, you can see how it works. And then the third and very important part is what's called a TCK, a Technology Compatibility Kit. In the case of Java, that's often referred to as the Java Compatibility Kit, and it consists of over 150,000 tests that verify what you've got in terms of a binary for the Java runtime matches the standard defined by that JSR. And it will test all different aspects of the system. It will test the JVM, it will test the core class libraries, all of those different things in order to ensure that everything works in the way that it should do. What's really important about that is it gives you an assurance that the binary you've got matches the standard. And so if you move from one provider of a Java runtime that is TCK tested to another provider of a runtime that's TCK tested, you have a very high level of confidence that your application will run in exactly the same way on both of them because they both pass the test. They're both equivalent in terms of the functionality. So let's talk a little bit about what we call the Zulu build of OpenJDK, because this is a binary distribution of JDK. What we do at Azure is we take the OpenJDK source code and we create what we call a slightly enhanced build of that. Now, again, very, very important is even though it is a slightly enhanced build of OpenJDK, it is fully TCK tested, and we ensure that it passes all those tests. So you've got this high level of confidence that if you want to move from a different distribution to Zulu, then there's no need to change any of your application code. There's no need to recompile your code. There's no need to worry about things behaving differently. In terms of providing support for older versions, we actually go all the way back to JDK 6. And so there is an OpenJDK 6 project. We use that source code, we build from that, we backport the changes from the current release all the way back to JDK 6. We then also support JDK 7, JDK 8, JDK 11, and in fact JDK 13, because we have something that's slightly different, which I'll talk about in a moment. A couple of other things that we've done in terms of this enhancement is that for JDK 8 specifically, we've seen that lots of people are still using that, and there's a couple of things we thought would be useful to those users, specifically flight recorder, so that if you want to use mission control to analyze your runtime, see what's going on with your application, then you can do that. And also TLS 1.3, that was ported, or that was made available in JDK 11. We then backported that to JDK 8 so that you can use that simply with the command line flag. Again, no command line changes and so on. We have wide platform support, so it's Intel 64-bit Windows, Mac, Linux. Also for people who might want to use older versions, then it's Intel 32-bit versions of Windows and Linux. And it is very much a drop-in replacement for other JDKs. Now, interesting from a Microsoft perspective is that this is something that we produced originally for Microsoft for the Azure cloud. That was the whole reason for us doing this work. And so if you're using the Azure cloud and you want to run Java applications on that, then the Java distribution that you will get for that will be Zulu. And in fact, all of the cloud infrastructure underneath also uses Zulu where it's using Java. Another thing that's important to understand is about the way that updates are provided. And the way that Oracle do this, and we at Azure batch the same thing, so we do an identical thing, is provide two different versions of each update. And what you get is the first version is what's called the CPU or critical patch update. That's the Oracle terminology. It's a security-only update. So only the security-related patches are included in that. The idea behind this is that if there is a critical vulnerability that needs to be addressed very quickly, you can do some quick testing on your applications, make sure everything starts up and runs. Then you can deploy this into your data center or onto your machines and make sure that you've got the maximum level of security for your applications. The second version is called the PSU, or Patch Set Update, and that's a full update, including security fixes, bug fixes, any minor enhancements for performance, whatever, any other source code changes. What you can then do is you can say, okay, I've deployed the security update, got my system secure. I'll then spend longer testing my applications against the update because there might be some things that have an impact. And then once I'm happy with that, I deploy that into my data center. So that gives you the maximum level of stability. How important is that? Well, it's interesting because if you look at the July 2020 update, that included in the full update, the PSU, there was a fix that fixed a problem, but also actually broke some other things. So it was a significant regression. Things like Hadoop Cluster, Solr, Lucene actually stopped working with update 252. If you'd had access to update 251, the CPU, that didn't include the fix that broke those things. So you could have deployed that. You could have addressed the highest score there, which was an 8.3 CVSS, and then you could have waited for the fix to the fix, which actually took nearly 2 weeks to create. So that's a good reason why you might want to have both the security-only update and the full update. In terms of extended support, as I said, there is no definition of long-term support. It's up to individual providers to what they do for that. So what we do is we make sure that we backport all the bug fixes, all the security patches for our supported OpenJDK releases. In terms of long-term support, what we've said is we'll do 9 years of active, which means 9 years of quarterly updates and any extra updates that need to be provided in between those, and then 2 years of passive support, meaning you can still report problems and we'll provide a fix. And then we've come up with the idea of medium-term support. So for 13 and 15, which are between the long-term support releases, we will provide extended updates to those until 18 months after the next long-term support release. So that'd be 17. That way, if you want to use features from 13 or 14 or 15 or even 12, then you can use those by using either 13 or 15 and deploying those into production. Just to summarize then, since I've got about a minute left, keeping Java applications secure from the point of view of the JDK. So Zulu builds of OpenJDK provide you with TCK tested binaries, updates with a time-defined service level agreement, so you know that you're going to get them within a certain space of time, all security patches, all bug fixes for all updates, both the CPU and the PSU, and 24/7 support issue reporting. So it's about maximum security, maximum stability, maximum flexibility for you as a customer. So that is basically the presentation on that. So I guess since I'm just on 25 minutes past now, if I stop sharing my screen and I go back to there. Okay, so let's see, do we have any questions, comments, anything like that? Oh, yes, brilliant. Great, good.
I don't think we have questions.
Okay.
Let me double check here on YouTube. Well, somebody at Zoho tried Zulu. Well done. That's one comment here on YouTube. On the one thing I thought about when I was looking at your, especially the first slides, you had one slide that talked about JDK 8, that up to an update, it's a license, and then another update, Oracle changed the license.
Yes.
But that is, just to clarify, that's specifically for Oracle JDK binaries,
Yes.
right? Not Java 8, because
Nope.
I think that's one of the confusions that people continue to have. Oh, Java 8 is not free anymore. Well, it's the Oracle Java 8 binary that is no longer free for production use.
That's right. So I do try to be as careful as I can about making that point. So if you want free binaries, then you can come to our website, and we have Zulu Community Edition, so you can get the Zulu 8 from us. There are other people who can provide that. So there's people like Amazon with Corretto. There's people like Adopt OpenJDK that provide free binaries. There's the SAP machine. Trying to think. Alibaba have Dragonwell. Bellsoft have a free binary as well. So there's the great thing is there's a nice choice of binaries that you can use. So you're not restricted in terms of only one or two. There's lots of different people who are providing versions of Java that you can use.
Yeah. The other thing that is becoming a challenge for many developers, especially in this transition from 8 to 11, and now from 11 to whatever version comes next, is managing multiple JDKs, especially in their developer environments, because one developer at a company is very likely they will be working at not just a single project, but multiple projects. And they may be dealing with a new project, but having to provide maintenance to a system that is already in production. So they have to be switching between JDKs. Are you observing that as well when you talk to your users and customers and developers?
Yes, to some extent. I mean, most people who are deploying into production environments are tending to go with the long-term support releases. So it's either going to be 8 or it's going to be 11, and then 17 when it comes out. There are a number of people who are also following the regular cadence. But one of the things that obviously makes a difference to this is the sort of kind of move to microservices architecture. And so people are deploying into a container, and that makes life a lot simpler because you're not using a centralized JDK instance and then having to worry, is this 11 or is it 8 or is it, whatever. So you just deploy into your container, you use assuming that you're on 9 or later, you use JLink and you create a runtime that's specific to your application, put it into your container and deploy that. And it just makes life a whole lot simpler. So that's one of the things I am seeing people do a lot.
Okay. Let's bring our next speaker, Dr.
Yes,
Heinz Kabutz. I think you know him.
I do. Where's Heinz? There he is.
There he is. Of course, he has his Crete beach in his background.
Well, doesn't look like this anymore. We had a big storm and it wiped out the beach. So,
so give us the
whereabouts
is the live streaming. I'm sorry. Go on, Simon.
So I was going to say, whereabouts in Crete are you?
If you Google Heinz, you'll find me. Or Java. Java's even better. Google Java, you'll find where I am. Now, this is a beach color thus. Obviously, I'm not down here, but yeah, it's really really fun listening to you because I use Azure for almost everything. All my distributions are almost always Azure JDKs because you've got support going back, back to whichever version. Java 9, you've got all the Java 9 support and Java 10, 11, 12, and I did a lot of research on Java, so I always need to know sort of what changed between Java 11, Java 12, and between 12 and 13, and so on. And it's almost always Azure. I use Azure except for Zulu, except for the very latest versions, and I run those on the OpenJDK. Right. But everything else is Azure Zulu.
Yeah. Cool, great.
So, Heinz, you're going to talk about Project Loom, is that right?
Yeah, I'm going to talk about Loom's ahead of us.
So, Simon, does Azure has a build of Loom already?
No, we don't, because Loom is outside of the standard, the mainstream JDK repos. So we're not actually sort of following. We have so many builds that we have to do that unfortunately we just don't have the resources to do things like some of the experimental stuff. We're just following the mainstream at the moment.
And it's anyway quite under development. So like the one I'm using is one I built myself from their website. Right. Mm-hmm. It's because it's changing all the time. So you want the latest version.
Yeah. So for people to understand, Project Loom it's considered like a side project at OpenJDK. You have OpenJDK B project, and then you have Project Loom. We had Project Amber and Project Valhalla, and all these projects are where ideas are coming to life. And then I think it was Project Amber that has been given most of the new features to the Java language in the recent times. Is that right?
Yes. Yeah, because Project Amber is all about the syntax of the Java language.
Okay. So, and Loom, just to give you a sneak peek, what is it about? What is the elevator pitch, Heinz?
Well, normally threads in Java are mapped one-to-one with native threads. So you make a new thread, it makes a new native thread. And the native threads are limited for two reasons. The operating system doesn't have context as to when a good time is to swap and how to swap. So it needs to, it's very expensive to swap. And the second part is that it's also quite expensive. Normally there are limits as to how many native threads you can start on a particular virtual machine. So, for example, on my Mac OS X, it's quite a beefy machine, but I can only make 16,000 native threads. With Project Loom, I can make millions. It just depends on the memory.
Okay, there we go. We just had the elevator pitch for Project Loom. I think we can skip the entire session. Is that right, Heinz?
Yeah, basically. You could do that.
That's definitely not. So I just want to say thank you, Simon, for your time. Appreciate you sharing OpenJDK builds and the great work that Azure is doing. For those that are not aware, there is a website that Azure is pushing and with great community support. It's called fuj.io. Is that the right URL?
That's right. Yes.
Fuj.
Yes.
Let me put it here on the fuj.io so the producer can put a banner for it.
Yes, and before anybody asks what Fuj stands for, it's Friends of OpenJDK.
So there are two O's. What does the second O stand for?
Friends of.
Like a bird.
Well, yeah, that's the symbol we use for it, the logo. But no, it's Friends of OpenJDK, Fuj.
Oh, okay.
Don't blame me. I didn't come up with the idea.
All right. Thank you so much, Simon. Have a great day, man.
Thanks a lot.
All right, Heinz, it's now with you. I'll leave it.
Right.
Thanks, man.
Let me put my screen share on, I presume.
Talk to you later.
Thanks, Bruno. All right. So here we go. So this is one of the really exciting projects that's happening in Java. And why do we need these? You've already heard my elevator pitch as to why these might be useful. First of all, I'm sure a lot of you have worked with asynchronous code, and when it works, and it's great. It's a really well thought out, and there are lots of little ideas. But if something goes wrong, it can be quite tricky to debug. So the reason why we would even consider that asynchronous code is because we are quite limited in how many native threads we can start. As I said in the preamble, with on my little machine, my little laptop, I can start 16,000 threads, and then I get out of memory error. So, and I don't even want to get close to that. And of course, we don't want to write systems where we fall over if you get a sudden surge of users coming to our system. So this is where Project Loom comes in. We can make millions of virtual threads in a single virtual machine. And it's supported with networking. So if you're waiting on the socket, your thread will be swapped out and by the virtual machine. And another thread will be able to swapped in. And if you're doing lots of networking, you're going to be waiting on the sockets most of the time anyway. And so it's a really good model. Similarly, if you are waiting on any of the Java till concurrent constructs, that is also compatible with Project Loom. And you'll get blocked out, you'll get swapped out, and other threads will be swapped in. So I've got a little scenario here. Let's say that you want to have a website which looks for really great deals. So you, first of all, scan the request for search terms, what to look for. Then you launch off a bunch of searches on partner websites. You also create advertising links because, of course, you have to make money somehow. So advertising will probably be the way. And then you need to collate the results from the partner websites and bring it all together and present the website. Now we can reorder some of these steps a bit. For example, we can create the advertising links first and then do the partners after that. But in the end, we need to have the final answer. And the simplest is to do it sequentially. So a request comes in, and we step by step go through it. We start the search. We go through all the partner sites one by one, do the request, search them, and then we do the advertising links. And then lastly, we collate the results, we get all the results, and we build this website, and we present it. And this is the simplest, but of course, we've got this whole problem with latency. It might cost us a few milliseconds to send them a request to the partner site and then wait for them to answer. In the meantime, we could do something else. In a way, it would be the easiest if we could just make one thread per request. But the problem is native threads are limited in terms of how many we can make. And so if we just arbitrarily construct new, more and more threads, we're going to get an out-of-memory error. So that's what we want to try and avoid. So I added some time budget to each of these steps. Of course, 42.5 seconds is unrealistic. If you take that long, they're going to go somewhere else. But just imagine that everything together, if you do it sequentially, one after another, will take 42.5 seconds, giving it some number. Now, we could use callables and futures and an executor service. And so what we could do is we could start the search on all the partner websites in the background using a callable. And we might get better performance because hopefully by the time we finish the advertising links, some of the background searches have already been completed. And so by the time we need them, maybe they're there. And so this is the code. I've got a callable. So the code before we added the search on the partner sites, I've just simply wrapped inside a callable Lambda. And I've did it explicitly just to show what's going on. So in the bottom of the screen, you see the callable there. Search the task, and I give that to my executor service. And now things get a bit tricky because the question is, what type of executor service should I use? Should I use a cached thread pool or a fixed thread pool? If I use a cached thread pool, I again run the risk that if lots of requests come in, that I run out of threads and I get an out of memory error. And if I use a fixed thread pool, I run another risk that if the system's busy, we start getting a backup queue of tasks which still need to be done. And of course, in that case, you might wait more time in the queue than you would have waited if you just done it yourself. It might exceed the 42.5 seconds by quite a big margin. But there's another problem, and that is that we are only fetching all of them together in the background, and we're really only doing the advertising links in parallel with the fetching. So our performance doesn't get much better than what we had before. Seems like a lot of work for not much gain. And of course, you could go for the, the Java 8 onwards approach of a completable future. And this is a great little model, completable future. Normally what you do is you draw down an activity diagram, and each of the different steps would be its own completable future, which is then executed asynchronously. And then you combine all of these with all of. I'll show you the code just for fun, but it is a little bit more complex. And it is faster because we can do more things in parallel, but it is a lot more complicated. And another thing you have to consider is, in this case, I'm going to separate the CPU-based tasks and the IO-based tasks. And the reason is that when you configure the sizes for your pools, you always want to make sure that you do it for the correct type of task you're going to do. If it's CPU bound, you want to have it pretty close to the number of hardware threads. And if it's IO bound, you're going to want it quite a bit larger than that, but not exceeding that maximum that will make your virtual machine crash with an out of memory error. So this complicates it even further. We can't use just the common fork join pool because, well, those common fork join pool threads are used also by other parts of your system for parallel threads, for example, parallel streams, for example. And so we can't use that, unfortunately. And so here's the code. I'm basically, every task has become a completable future. And I've got, for example, at the bottom for the advertising links, I've got my own completable future, which does it asynchronously using the render pool. And then I've got another one which does the scan for search terms again with the render pool. And then further down, I've got the search on partner site with the download pool. So I've got different pools for each of the tasks. And it's like 3 slides instead of 1 slide, which is great if you're counting lines of code. And our performance is actually not that bad. We could get it to be faster, but I have limited the number of threads in the download and render pool to be a bit more realistic, because if you have an infinite number of threads, well, that'll be great, but not really what you're going to do here. I've got a little gift for you if you're interested. Go there, tinyurl.com/JDConf. You'll get a gift. It's an offer which expires at the end of this talk, so if you don't get it before then, you won't get it. So if you're watching the recording, sorry. Here's the link again. Now, we get to this idea of Project Loom and virtual threads. The virtual threads are very lightweight. Typically less than 1 kilobyte, but it depends what you do with them. They are very fast to create. I tried a little demo early on today, and I made 23 million virtual threads within 16 gigabytes of memory. So I've got a 64 gigabyte machine, and 1/4 of that is allocated by default for my memory, and so I made 23 million virtual threads. And it's just a bit over half a K. It's about 600 bytes, but it depends what you do. In some cases, it'll be a bit more. I've seen it go sort of 1.5 kilobytes, but round about there. And the actual threads that execute these virtual threads are what we call carrier threads. And the carrier threads are by default at the moment normal Java threads from inside a fork join pool. Fork join pool is a really good option for this type of for these carrier threads because it's good at executing short jobs. However, you'd have to be careful because we managed to exceed the queue size of the tasks on the fork join pool. So we actually created too many virtual threads too quickly, and the task queues of the fork join pool are limited to 64,000 tasks. And so we actually blew that budget. You've got to be careful. Something else is that the the carrier threads are by default daemon threads. So you need to make sure that all your work is completed before you actually exit from whatever method you're using there. The number of threads in the fork-join pool is by default the number of available processors in your system. So the number of hardware threads. And this can temporarily increase due to the managed block. I'll talk about that again in a second. And what's also really cool is that if you have a virtual thread and the virtual thread blocks on I/O or sleeps or waits on a Java concurrent construct like a blocking queue or entrant lock, then that virtual thread basically gets swapped off the carrier thread using continuations, and once it's ready to do some more work, it gets swapped back on again. And this is all happening without us having to change our code. Super convenient and really great system. Let's get back to the single-threaded renderer. So this is what we started with, and we had all this code of one after another, and if the threads were unlimited and free, why don't we just create a new virtual thread for every single task? Now, of course, nothing is unlimited in the world except for human stupidity. I think that is unlimited and knows no bounds. But besides human stupidity, threads do have a limit. You can't make unlimited number of threads. I wrote this one experiment and I was running it to see how many threads I could start. And I would start a thread and park it, and then start another thread and park it, and start another thread and park it. And it ran and ran and ran. And I let it run overnight. And the next day I looked at it and I said to my colleague, I said, hey, John, look at this. We've got 17 billion virtual threads started, and they're all parked. And then I sort of did the math and thought, wait a moment. I've only got 16 gigabytes allocated to the process. So is it like less than 1 byte per virtual thread? No, of course not. So that was a failed experiment, and my experiment was flawed. That's why it seemed like it. So nothing's unlimited, but the limit is really high. It's much, much higher than what we're used to. All right. Now, here I'm creating a new virtual thread for every task. So what I'm doing is, first of all, I'm starting a virtual thread to create the advertising links. That was the third step. Then I scan for the search terms. I do that with the current thread, and then for each search term, I start another virtual thread, and the virtual thread will search on the partner sites and then collate the results. So that's how I do it. And then I get back a collection of all the threads that were launched like that. Now, launching these threads is really cheap. So launch. And then afterwards, I join all the threads which I've started in order to make sure that I'm finished with all the rendering before exiting from the method. So I wrote this code and I thought, doesn't feel that great. It just, it didn't feel so good, and but the speed was great. From 8.5 seconds down to 4.5 seconds. So in fact, from 42.5 seconds all the way down to 4.5 seconds. So really great performance, but it didn't feel good doing all these joins. I didn't like the joins particularly. Also, if you look at the top, you'll see there's an interrupted exception being thrown from the method. Again, it's like, why do we have all this stuff? So there are two ways you can create these virtual threads. Either you can make individual threads with thread.start virtual thread, and they've added a thread builder, which allows you to make a normal thread builder. You can specify whether or not you want thread locals, etc., and then start the one thread. There's also a virtual thread executor, which will just construct more and more threads uncontrollably until you're done, until you finish with your program. And what's really cool, really super cool, is that executor service is also now auto closable, and the close method calls shutdown and then await termination. So that's a really great feature, and I believe this is actually not directly only because of Project Loom. I think this is coming into a Java version fairly soon, and this allows you to do something called structured concurrency, where I'm saying try I put in there, I create a new virtual thread pool. And remember, these things are very cheap to create, so we can just create them without worrying about the cost. And then I've got I submit my one job as where I create the advertising links. And then another thread, another job where I do the other work. But internally, I've got a nested executor service which I put in there. So and because they get closed at the end, I'm also sure that everything is completed by the time I exit from the method. So this is really a nice way of working. Time is the same as before. Now, there are some things to know. Managed blocker is one thing. Managed blocker allows the fork join pool, which is what the carrier threads are using, to create more threads if you block. And in Java 7, only the phases supported this, but Java 14 abstract queued synchronizers supports that, which means reentrant block. Therefore, all the blocking queues also support this. So this means that if you do have to block, your fork join pool will create additional threads to keep your parallelism high. So this is also really convenient. Now, you might need to implement this in your own code base. Have a look in the JDK how to do managed blocker. The Java IO implementation was rewritten. So in Java JEP 3.5.3, they re-implemented the legacy socket API. So they took the plain socket impl and they replaced it with the NIO socket impl. And then the JEP 3.7.3 re-implemented the legacy datagram socket API. And when I saw these numbers, I thought, this is like, I can imagine them like when you try and get a really cool license plate number, you're like waiting for the numbers to tick over so you can get the really good number. So I wonder if they were waiting for the JEP to tick over until the number 3.7.3, and then, let's get that on as well. So 3.5.3 and 3.7.3, easy to remember. I don't know. Anyway, something to remember is that at the moment, synchronized wait is not yet compatible with Project Loom. And what will happen is that the virtual thread will store the underlying carrier thread and won't allow it to be swapped out. And this happens specifically if you call a native method whilst holding a lock. And monitor.wait is a native method, therefore synchronized monitor is at the moment not going to work. So if you here are making as many virtual threads as I've got hardware threads, and that's how many carrier threads I've got by default. And so when I try and add one more virtual thread, it won't actually be executed. So everything will just stop. So don't do that. And but the synchronized works. Synchronized works in general. It's just if you wait, that's not going to work at the moment. But they are working on fixing that sometime in the future. So we might have to change our code to use reentrant lock and stamp lock. And in both cases, reentrant lock and stamp lock, the idioms are more complicated, but at least you can be compatible with virtual threads. Another thing which might have an impact on your system is that biased locking is turned off by default. And I understand that biased locking does complicate things quite a lot. And so what they've said is let's not keep on supporting that going forward. Biased locking should not have a huge impact on your performance. But I have got some benchmarks that show concurrent hash map being 3 times slower in an environment where you don't need locking. So if you don't need synchronization, you don't need thread safety, but you're still using concurrent hash map, it might be 3 times slower with biased locking turned off than with it turned on. But I'll be very surprised if in your real application you would measure a difference. But this has been off since Java 15. So what you can do is if your application runs slower in Java 15, turn it on again and see whether that makes a difference. I would be very surprised if it does, but please report if it does make a difference. It shouldn't. And if it does, you might have to find the place where this is a problem. It's not so easy to find these. Good luck. Also, thread local is problematic. There's a better solution with Project Loom called scoped variables, which you should rather use. And they weren't sure about whether they should support thread local or not. They do, but you can turn it off. Thread locals also often don't make sense because virtual threads don't get reused. They're so cheap to create, they just get thrown away afterwards. We've got a server running at the moment where the server component has 2 million sockets open and 2 million virtual threads on a little machine. It's not a huge machine. It's got 6 cores, 12 hardware threads, and 2 million virtual threads running right now. And all I'm doing is pinging backwards and forwards with the clients. The clients are running on the same machine, one huge virtual machine with, again, 2 million virtual threads pinging backwards and forwards. And when I first wrote the code, I did the client code with an input stream reader and a buffered reader to read the data and a print stream to write the data. And I couldn't understand why the client, because I did that on the client, used so much memory until I did some investigation into these streams. So this is something which really surprised me. The print stream uses 25 kilobytes per print stream, right? And if you only use 3 print streams, it really doesn't make a difference. But if you create 2 million print streams, all of a sudden you've got 50 gigabytes of memory just wasted, an empty space of buffers for print streams. Your buffered reader is 16 kilobytes because it's a 8K char array, which is 2 bytes per char. And then you've got the adapter, which is 8 kilobytes, input stream reader, 8 kilobytes. So altogether, it's like 50 kilobytes per buffered reader and print stream pair. So be very careful with that code. I'm very excited about this Project Loom. I think it's a great job. You can download it from the Project Loom website already. Play with it, try it out. Obviously, if you're using production, make sure that you check your check your server regularly. Before I got onto the talk, I checked my Java Specialists EU website, the link here, and I discovered to my horror that I forgot to renew my SSL certificate. And I discovered it like 15 minutes before getting on air. So, oh no, this is terrible. And it takes a bit of time to renew that. So if you go there now, you'll see insecure. Don't go there. Hopefully, it'll be working properly again tomorrow. Don't forget the gift, and do try out Project Loom, because it's a project which has a lot of potential, I think. And it should make debugging of our systems a lot easier when we can follow one stream from top to bottom rather than all sorts of asynchronous method calls that are sometimes very hard to follow. So that's it from me. Do we have any questions?
Hey, Heinz. First of all, congratulations. That was a great talk. We got some great feedback from Twitter. Not Twitter, I'm sorry, YouTube.
Oh, cool.
There's one question here. If a framework heavily relies on thread local, such as Spring Security, can't they move to Project Loom now?
Yeah, it could. You can use thread locals. They actually are on by default, but it is recommended to move away from that because each time that you've got a thread local, each time you set a thread local value, it creates a thread local map, and that's quite expensive in terms of memory usage. I'm not sure how much it uses, but it's substantial. So recommended is to try and move away from that at some point.
Okay. One question that I have.
Okay.
A few months ago, I was benchmarking gRPC servers in Java, and I came to the point I had to deal with thread pools. Once we moved to Loom, yeah, I think you saw that.
Yeah, we had a discussion about that. I do remember. Exactly.
Yeah, you went to the GitHub issue and you said, "No, Bruno, you're all wrong. This is how it should be done."
No. Your benchmark's wrong. Not you. You're not wrong. You're right. Just the benchmark is flawed.
So the question I have for you is, with Project Loom, do we still need thread pools?
No, all you'll do is you'll just say start virtual executor service or virtual thread executor, and you're done.
So no need for the thread pools.
Well, that is an executor service. I saw there was one question about callable. You can submit callables to the threadful executor. No problem. You can work with callables, futures, all of that. You can even work with computable futures. All of that is completely operational together with Project Loom. So they work together. You still have the higher level threading constructs. But for your, was it GPRC or whatever it was, for that, you would simply pass in the virtual threadful, and or rather virtual thread executor, because it is not technically a pool, because the threads are always thrown away afterwards. They don't go back into the pool. You make them, throw them away, make them, throw away. They're so cheap to make, you might as well throw them away afterwards.
So it's an executor service, but there's no need for a thread pool algorithm in the behind the scenes to be managing those threads, because you just create one, you execute, and you're done. That's
right.
it.
Right.
Okay.
Exactly.
I should try Project Loom on my benchmark.
Yeah, you
once
should. You should. You'll
once I
get
make it,
amazing results with that benchmark of yours.
I'll give it a try. We have our next speaker, Reza Rahman. Where are you?
Reza.
Oh, there he is.
How are you, sir?
How are
How are things in sunny Greece these days?
It's been quite rough, actually. It's been really rough the last few couple of weeks. We've had real big storms, but yeah, otherwise it's good. How are things in your side of the world? Where are you now? California?
In Philadelphia, yeah. No, I'm in Philadelphia. I'm still been
right.
for a long time. Things are good. I think we have a responsible local government here. Thanks to that, we've effectively locally flattened the curve. So it can be done. It's just you have to, have the willpower to do the right thing. That's all.
Yeah. You have to work hard.
Awesome. Reza, where in the Java EE space, which is your next talk, do you see? Oh, Heinz, come back! Don't.
Yeah, I'm just. I'm turning screen sharing off.
Yet. Awesome. Where do you see Project Loom becoming an advantage for Java EE developers in the near future?
Java EE, actually, as you know, these days the Java ecosystem is very, very performance conscious. I'm pretty sure things like Open Liberty and Quarkus and all the rest are going to be paying close attention to what's going on here. Thread creation obviously is one of the weak points in Java EE, and why things like Node.js and the like, make claims about better performance, right? So I'm pretty sure the ecosystem is paying close attention, and I don't think what's going to happen is Java EE always tries to be a ease of use abstraction layer. My guess is a lot of these will be consumed at the runtime level rather than necessarily at the programming model level, but I'm pretty sure that won't inhibit. I'm sure there's also something called Java EE, or these days Jakarta EE concurrency. I'm pretty sure one thing that can be done there is create managed versions of these and create sort of more lighter weight EE abstractions over these APIs. But it's certainly very interesting to see and very timely. It sort of makes it possible to continue to use the Java programming model. I see threading as one other aspect of why Java is better than something like C, right? Just like you don't manage memory pointers, you don't manage threads yourself either. The runtime does that for you. So it's good to see that we don't have to abandon that and suddenly embrace a much more complex programming model. Like some of the reactive things that are experiments that are going on in the Java ecosystem. I think if this can solve that problem by still retaining that abstraction level of keeping Java so-called a blue-collar programmer's language, I think that'll be a good thing.
I don't see reactive going away. I think that's going to be with us for a very long time.
Sure.
Despite Project Loom, because there's a lot of thought has gone into that.
I agree. So Heinz, thank you so much for your time. I hope the weather is better over the weekend. I hope that the weather looks like exactly as you have in this picture here very soon, so you can go on your run in the morning and not have to deal with capes and all those waterproof gear that you have. So thank you so much for being here with us. All right. So bye, Heinz. Reza, we are at your time, so just take it over and get started. Thank you for being here.
Okay, let me know if everything is okay, please. Just a quick systems check. Can you see my screen at the moment? Bruno, are you still there?
Yes, we can.
Okay, you can see my screen. All right. So I don't have a whole lot of time, so I'm going to get started here. The primary objective of this talk is pretty much I'm doing my day job as Principal Program Manager for Java on Azure at Microsoft. I'm going to be sharing with you the work that we are doing on behalf of Java EE developers and Java EE customers at Microsoft. And also, part of the objective here is not just a one-way street in terms of telling you what's going on, but also this is your opportunity to engage with me, engage with us as Microsoft, and tell us what you would like to see us be doing. And at the end of the talk, I'll provide a concrete mechanism that hopefully you'll be able to do just that. So in the next 25 minutes or so, this is my plan for you. We'll be talking a little bit of the Java ecosystem context. I think all of the work we do is in the context of a broader ecosystem, and it helps to understand, at least from the Microsoft perspective, what that ecosystem view is. We'll be talking about what is currently possible today, and a lot of it is possible. So one thing that we should acknowledge here is Microsoft traditionally has not really focused on Java EE, or even broader, in broader terms, the Java ecosystem. But I think in equal terms, you also have to say that, as you'll see in a moment, I suspect we're doing much more than even some of the core traditional Java players to better serve Java developers and Java EE developers. And in that vein, I'll finish off by talking about what is the work that we still have to do and how you can potentially help us. So the ecosystem view, as you know, Java EE remains important. If you have any doubts whatsoever, you really should not. Even now, there's between a quarter and 35% of Java workloads that work on application servers. We see these type of workloads on Azure all the time, more and more, even us, in the state that we are in, that we're not necessarily seen as sort of the center of the Java universe. Even we see these sorts of workloads come our way. It's very, very much relevant. Of course, outside of the Java application server realm, Java EE is even more important. You know, there's almost every single server-side Java developer is using Java EE APIs in one shape or form or the other, whether they realize it or not. So tremendously important ecosystem. It's also a very healthy, diverse ecosystem. It is evolving. We are taking a look at some of these evolutions. We'll talk about this very briefly towards the end of the section. But certainly things we are keeping attention to is things like Quarkus and Microprofile and Helidon and all of the other interesting things that are going on that are bringing this ecosystem, thriving ecosystem forward. So there's some data there. You can take a look at the Jakarta EE developer survey. I think there's some very interesting insights there worth looking at. So as we also probably know, this is an ecosystem in positive transition. You know, this is, I'm proud to say I had something to do with this. So Java EE is no longer Java EE. It's now in its new reincarnation as Jakarta EE, much more open, truly multilateral under the Eclipse Foundation. There'll be Jakarta E9 almost at the door. Actually, I was hoping to say, you know, we don't have to say Java EE anymore. We can just say Jakarta EE because the transition is complete. But it is going to be complete in very, very, very soon. And of course, hopefully next year, we will see a Jakarta E10 release that will add more innovation features and really make the transition solidify. And at that point in time, I'll probably rename this talk to you know, Jakarta EE roadmap rather than Java EE roadmap. But so far, I think pretty much Java EE still is the mainstream technology that we are targeting, at least from a Microsoft standpoint, right at this moment. So I think one of the reports that really do a good job of crystallizing these sorts of evolutions is the InfoQ1 from this year. Basically, Jakarta EE hasn't quite crossed the chasm yet. If it were, as I said, I'll probably have renamed the talk of the title in terms of Jakarta EE, but it is getting there, and there's also healthy evolution and newer parts of the ecosystem that are bringing fresh ideas and fresh perspectives into the ecosystem that we're keeping an eye on. Okay, so this is the current state. It's sort of I intended this sort of as a map. These are basically the different pathways that you can enter Azure or enter in general any cloud, and these are the sort of components in that pathway. These are the actors in that pathway that we observe. Again, this is based on not just industry data but observable data in our own customer domain. So you have virtual machines, you have containers, namely things like Docker, Kubernetes, OpenShift. You also have managed services or PaaS, so entirely managed platforms. These are the three different arcs in our pathway. In virtual machines, we have a decent story. I'll talk about that in a second, but these are the players that ultimately we need to think about in the virtual machine space. Same thing for containers and Kubernetes, and the other thing for managed services. Now, one thing I'll note here is the Pyara folks. I won't be talking about Pyara too much, but I will say this during this particular slide. They're actually one of the players that have gone above and beyond in terms of supporting Azure by themselves. They've done so much. Honestly, we don't even need to do so much on our end because they've already cleared all of these pathways, the majority of these pathways in terms of Azure. So that's the reason I won't mention them, but you're well served on Azure if you're a Pyara customer in particular because of the work that they've done proactively, even aside from Microsoft. So virtual machines, this is like the poor man's way into the cloud, if you will, but it's tremendously important. To be honest, this is probably one of the continues to be the biggest revenue maker in terms of Microsoft, of how people are using the cloud. This is just VMs on somebody else's cloud, in this case on Azure's cloud. So obviously, the basic thing that Microsoft has done, for a while now, you've seen Satya's statements about Microsoft loves Linux and so on. That is the key crux that actually enables this entire Java on Azure and Java EE on Azure story, right? So having all of these mainstream Linux runtimes, all of the popular ones, in addition to Windows, really is what powers all of this work from happening. But aside from that, we actually also have this concept of virtual machine images and solution templates, right? So you have the virtual machine images, and in fact, we have more or less virtual machine images for a majority of the application servers. But we also have this, again, this capability of further building on that, sort of give you a blend of a PaaS experience and a virtual machine experience through these virtual machine templates. And a good example of that is the work that we are doing with WebLogic that enables you not to just have these images, but also do much more powerful things based on these images, like very easily be able to create clusters, very easily be able to integrate with load balancing on all of the Azure services. Now, there are gaps here. As you can see in this picture, we currently do not have a virtual machine image for the WebSphere family, which something we're working on. I'll talk about that in a second. Currently, the JBoss and Wildfly images, those are third-party images. These are not first-party images where we have, it is a result of a robust partnership between Red Hat and Microsoft. But again, these are things that we're working on, and I'll talk about that in a second. So I talked about the robust partnership that we do have with the WebLogic team and the work we are doing there. So we have had a couple of strong releases of this offering. So basically, these are robust, up-to-date, jointly developed and supported VM-based offerings for WebLogic. It supports a number of use cases. So definitely base image, definitely spinning up a simple single instance very, very quickly. Clustering, load balancing, integration with Azure Gateway in terms of load balancing, integration with all of our database service offerings, including also integration with Oracle DB on either Azure VMs or the Oracle Cloud via our interconnect, integration with Active Directory. So a whole bunch of use cases already covered. Please try this out. I think you might be pleased, especially if you're a WebLogic developer. There's a quick link to this. You'll see it in the slide. I'll share a link to the slide towards the end of the talk, so you can quickly explore this and take a look at it for yourself. There's also similar work that we're planning to do with WebLogic on Kubernetes, or WebLogic on AKS in particular, in terms of Azure. Okay, so Azure also is a very good home if you're a container developer, right? So we have a best-of-breed Kubernetes implementation called the Azure Kubernetes Service. We also have a container registry to go along with that. It's called the Azure Container Registry. And if you don't want to do all of that, another nice option is if you just want to use Docker and don't want to use full-blown orchestration, app service for containers is a good choice for that. So typically, what application servers vendors do in order to provide robust support for containerization is first and foremost, provide Docker images. But above and beyond that, in order to better support orchestration, the application servers can offer Helm charts and ultimately Kubernetes operators that often built upon Helm charts. And the majority of the Java EE application servers are no slouches. They're doing just all of those things for you, right? So JBoss EAP, Wi-Fi, WebLogic, WebSphere, OpenLiberty, all of the mainstream Java EE players have some kind of robust containerization and orchestration and Kubernetes story there. Now, you could, again, do a lot of this yourself. So if you have the foundational infrastructure, just like in VMs, in theory, you could be doing anything you want. But in reality, there's also things we could be doing on our end to make that pathway as easy as possible. And we have begun that work as well. In particular, we have a reasonably robust story with the WebLogic team that's going to get even more robust. But we've also started the story for the WebSphere and OpenLiberty suite as well. I'll talk about that in a second. So there are gaps here and areas of improvement, but again, relatively strong story here as well. Speaking of, let's talk briefly about our WebLogic and AKS work. So what we're doing here is basically WebLogic has a very well constructed operator. We are working to we're actually now officially supporting that operator on AKS. We've tested and validated that it works. It's fully supported by both Microsoft and Oracle. You'll see a short link to that work, and we've also provided some scripts, examples, and guidance to help you along that path if you want. But again, we are looking to create something similar to what we've done for virtual machines using the marketplace template solution. In other words, abstracting all of this work so that it just becomes sort of foundational infrastructure rather than something you need to consciously think about doing. Right? So please explore that work. OpenShift is reasonably popular, at least with some segment of the market. So this is basically an abstraction layer above Kubernetes. And this abstraction provides a number of essentially points of flexibility, right? So you can have multi-cloud, you can move between cloud providers, you can have hybrid deployments between your local data center and the cloud. So a number of use cases are enabled through Kubernetes to some extent, but also through OpenShift. So actually, I believe outside of the Red Hat cloud, Microsoft was one of the first cloud vendors to provide a managed Red Hat OpenShift offering. So we do have that. And in that Red Hat OpenShift offering, you have all of the major images available through in that Red Hat OpenShift offerings, things like JBoss EAP, Liberty, OpenLiberty. But again, the foundational infrastructure is there, but we could be doing more, right? So in fact, we are doing more, specifically with the OpenLiberty and WebSphere Liberty team, to better improve and smooth out that pathway for you as well. In terms of managed services, this is traditionally a strong point for Azure. If you were to say, okay, what makes Azure special, this would be one of the talking points. Is we have a number of robust PaaS offerings. So for a while, we didn't have a managed Java EE PaaS offering. This was sort of a focus area for us for a little while, but no longer. We actually have finally a JBoss EAP on App Service. So this is our App Service is our premier managed services platform, and now we have support for JBoss EAP on that. It's still in public preview. Hopefully, it will go GA very soon. Right now, it's very good for stateless use cases. So it's stateless, load balanced, auto-deployed, auto-scaled, monitored. Again, it's jointly developed through partnerships with Oracle. Not often, but almost always when we're doing this work, we're doing it along with a partner in the Java ecosystem. Again, this is something you should try out, give us feedback, improve it, make it GA, and get it ready for a production release, hopefully soon, out of public preview. But this is an area that really could use your active feedback. Okay. Another very interesting and I think very useful offering is JMS support in Azure Service Bus. So Azure Service Bus, if you're not familiar with it, is basically the de facto managed messaging platform on Azure. You can run other messaging solutions, but this is basically the flagship messaging product, if you will. It is rooted in .NET, so a lot of Java developers are probably not familiar with it for that reason. But that hopefully is changing now, especially with this offering. So now we have a public preview of JMS2 support in Azure Service Bus. So this was possible for some time, because Azure Service Bus foundationally supports AMQP, and if you use Apache Cupid, you can have a bridge between JMS and AMQP. But the problem was that Azure Service Bus did not fully implement JMS. So now, hopefully by December, we're going to be announcing full compatibility with JMS and taking this feature out of public preview into GA, hopefully no later than, let's say, early next year. And that will make it possible to be consumable in all kinds of applications, certainly including Java EE applications. Of course, this is not the only way of accessing Service Bus. For example, Service Bus has had a sort of native Java API for a little while. But again, if you're interested in this, please check out the link, try it out, give us feedback, engage us. Okay, so I won't have time to demo this. I'm just going to show you the location of this demo. If I had enough time, I would do this demo for you. But please go take a look at this GitHub example. It's basically, if you've done nothing with Azure at all, and if you're a Java EE developer, if you try this demo out, it'll at least give you a flavor for how your experience might look like. So take a look at that. All right, so I think this is a good point for us to talk about the future and what is it that we are working on currently as opposed to what we've already done. So this is another map, and this one is going to be an annotated map. So as we talked about, there's certain areas where we've made pretty good progress, right? Already talked about, I think, probably better progress than most of the mainstream cloud vendors out there. WebLogic on virtual machines, the JBoss CAP on app service offering, the JMS support in Azure Service Bus. Those are all very strong progress, I would say. There are areas that we are working on. Talked about some of this already, right? So we're doing some work to improve our virtual machine support for JBoss CAP. We're doing similar work for WebSphere traditional on virtual machines. And again, we have doing some similar work to better enable Wildfly on virtual machines as well. Same story for JBoss on OpenShift. In the images there's room for improvement on how that could be better. There's some basic work that we've done in terms of guidance for running Wildfly on AKS that could use more improvement and be more robust, and we're working on that. We are actively working on the WebSphere Liberty team to improve our support for running WebSphere Liberty on OpenShift. I'll talk about that work in just a moment. And of course, there are some gaps as well. These are things we will address as we go along. These are areas that we're aware of that we need to work on. So that would be JBoss CAP on AKS, WebSphere Liberty on AKS. We'll tackle that right after we address WebSphere Liberty and Open Liberty on OpenShift. Our next target is doing the same for AKS. And Azure Redis is a particularly interesting one, especially for Java developers. Redis is surprisingly popular, and there's many different ways you can use Redis. You can use Redis as an app server cache. You can use Redis as a Hibernate second tier cache, or you can use Redis directly through JCache. So these are some of the use cases that we already know that our customers want and are doing to some extent by themselves, and things that we are mindful of and we will try to address. Okay, so already talked about the WebLogic on virtual machines work. Just to visualize that, we've done quite a bit of progress here already. The things that are not quite done yet, and we are working on, is integrating Oracle coherence support within that virtual machines offer. Adding support for nice integration with the Elk stack, which is tremendously popular with Java developers on Azure, and also providing some additional migration tooling and guidance. There is some migration guidance overall. Wherever we feel like we have sufficient material, we tend to write higher level migration guides for that pathway. So again, we'll continue to do that here in addition to doing migration tooling. Okay, so the WebLogic and AKS work, again, we've done some work here. We've certified that it works. We have provided some simple guidance to integrate with things like Azure files as a persistent volume and be able to run WebLogic clusters in a robust way on AKS. but there's a lot of other work that is still on our horizon, namely making sure that all of these other integrations all work for you in a robust fashion. So we have initiated the work with the WebSphere and Open Liberty team to enable OpenShift to start with. Right, so over here, we have enabled so far that we're going to announce very, very soon. So this is almost late breaking news, is to enable very easily running a WebSphere or Open Liberty cluster on OpenShift. So this is guidance to smooth out all of the rough edges in the experience. We've also done some initial work to demonstrate how to integrate Open Liberty and WebSphere Liberty with Azure Active Directory. Of course, that leaves out a bunch of other integrations, namely integration with a full suite of databases, including DB2, as well as already talked about ELK. In terms of caching, we want to support Azure Red Hat Data Grid running on OpenShift, as well as Redis. Right? So this is a case where WebSphere and Open Liberty, because of its pluggable nature, can actually support Redis as a second level cache. Okay, so talked about the initial work that we're doing to enable Wildfly and JBoss CAP a bit better on virtual machines. So this will hopefully turn into jointly developed and fully jointly supported virtual machines, and hopefully down the line solution templates for running the software on Azure, as opposed to the third-party offerings that are there right at this moment. It's still a work in progress. So right now there is quick start templates under the hood. Basically, all of the things that are in the marketplace are actually quick start templates. So this is a good initial first step to get us there. Right now it's community provided, but we're going to make this more robust and make it a joint offering, just like we're doing for WebLogic, joint offering between Red Hat and Microsoft. Okay, so I'm going to finish up here. So basically, the basic message here: we are here for you. We're doing as best as we can to make these use cases robust. We need your help, and there is a way you can engage with us. Right? So you can fill out the survey, and you can provide your feedback on what you would like to see in terms of Java EE on Azure success. But more importantly, if you would like to engage with our team and help you in a migration scenario by providing whatever you need, and in the process improving our offerings, that is something we would very much like to do. So if you take one thing out of this talk, please take away this survey link, fill out the survey, leave us our contact information, and begin engaging with us and working with us. So again, we're working to enable all of the pathways, including containers and virtual machines. The PaaS is on the way. And integrations are also there for the most part, but again, we are working to improve all of those stories as well. So I'll leave you with a few links. I won't describe these links here. They're largely announcement links, official announcement links for all of the things that I talked about. Right, WebLogic on VMs, JBoss CAP on App Service, so on. So please take a look at all of those. See what you think of them. And again, most importantly, engage us. So I think that is all I have. I'm just about at time. And what I'm going to do here is in the chat, I will leave the URL for this talk, just so you guys can take a look at it, and also refer to the material that I talked about.
All right. Thank you, Reza. I'm going to paste this on the YouTube chat, Reza's deck. And please feel free to also share on your Twitter account. I know you have a GitHub profile as well with demos. If you can point that when you tweet or post on LinkedIn, like the deck and the GitHub samples that you have for Azure and Java EE stuff, that'd be great.
Sure.
I got one question here in the chat on the YouTube live stream. Does Microsoft plan to become a strategic Eclipse member and participate at Jakarta EE working group?
So that's an interesting question. I'll answer it from a personal standpoint and a Microsoft standpoint. So a personal standpoint, I sure do hope so, right? Because I definitely think we can make a difference there and become truly a core part of the very important section of the Java ecosystem. From a business standpoint, I think we first need to make the business case, right? So this is where we need people to engage with us and tell us our pain points and really prove out the case that there is a business to be made here. There's a market to be made here. There's mindshare to be won here, right? So the way to make that case, begin to make that case, is engaging with us, and that's how we make the business case for Microsoft, or making that happen beyond simply my opinion or somebody else's opinion.
I do recall that the JMS support on Azure Service Bus came because of customers asking for it, right? They had their legacy applications, they wanted to bring them to Azure, but they wanted to leverage Azure services and the Azure platform in general for their scenarios. And that was one of their one example. That's one example of that sort of engagement that you were expecting, that customers and developers come to Microsoft and say, hey, I would like to develop Java EE. Can you make my life easier? And we saw that happening with JMS on Service Bus, and hopefully we're going to see that with other parts of Java and Jakarta EE as well. And as you said, justifies our participation in the working group at the Eclipse Foundation.
Plenty of examples. JBoss CAP on app services, and you could cite many examples of this, but that is really the key, is engaging with us.
Excellent. We have our next speaker. I just would like to bring Rich Turner on our virtual stage. Rich, where are you? All right, we got Rich. How are you?
Can you hear me?
Yes, we can hear now that
good,
you unmuted your Yeti microphone.
Virtual conferences.
So virtual conference stages with lots of buttons to unmute your microphone. Rich, your session is about developing Java on Windows. As we've seen time and time again on developer surveys, Windows is still like one of the most used operating systems, not only at the corporate environments, but also by the many developers around the world. Sometimes even like students and people who just, they happen to have a laptop with Windows. Not everyone get a Mac, right? That's the reality. Yep. And funny fact, the only time I started working with a Mac was at Microsoft. And I don't know what happened there, but I apologize. Reza, I think you are on a Mac as well. Is that right?
I switched bit, actually. To be honest with you, I really I know this is sacrilege, but I really prefer Ubuntu. I have a Linux laptop, but yeah, I have a Microsoft sanctioned Mac as well that I rarely use because I prefer the Ubuntu laptop.
Which is fine because. No, which is fine because Rich will actually show Ubuntu on Windows. Is that right, Rich?
Yeah, absolutely. The beauty with Windows now is with Windows Subsystem for Linux, you can run Windows alongside Linux, multiple flavors of Linux if you wish. So if you live both in the in the SUSE and Ubuntu world, or you prefer one to the other, you can have both environments. And we've got some exciting stuff that we're working on for the next version of WSL, which we'll be covering in the session as well, so that you can choose as to whether you build your stuff in Windows for Windows or in Linux for Linux. We obviously can't run Mac alongside everything else right now, but that's why you need to buy Apple hardware if you want to live in the Mac world. But yeah, it's the boundaries between these things are starting to decrease to the point now where it's going to become a lot easier to develop for the target platform that you aim to deploy to.
Have you ever seen, Reza, the situation where a Java EE developer, especially in the old days of 2008 Apache struts and all those things, funny things that we were doing with Java EE back in those days, a developer working on Windows but having to deploy on a Linux server and all the issues that could happen because of that? Do you have any story you want to share?
The biggest story is file paths. So, people are they're loading a file or have some kind of file reference or log file, and it almost invariably fails when you do the deployment. And, those paths no longer work. Even though Java actually does try to act as an abstraction layer to disambiguate the file paths. But if you have a hard-coded Windows path, there's no way Java can do anything with that. That's going to fail immediately.
Absolutely.
when you run it on the Linux environment. Yeah, plenty. But those are the principal ones. Of like, and it happens.
That's a great scenario and example. Why a developer on Windows who will deploy in production on Linux should be learning and using Windows Subsystem for Linux, right? Because they can continue to use the IDE on Windows, but making sure that they run and test on Windows Subsystem for Linux and making sure that it will run on the Linux environment. So great stuff. Reza, thank you so much for your time. You have a wonderful rest of your week and weekend, and we'll talk later.
Sure. Okay. All the best.
All right. See ya. Rich, thank you for being here. I know you're a Windows guy, a .NET guy, and I've been saying this throughout this conference, and it's a pleasure to have you here, actually. And I heard that you learned a few Java tricks, and you're going to share some Windows tricks for all these Java developers on Windows. So please take it over. Thank you for being here.
Thank you for inviting me on. We've been talking about this, I know, for a good few weeks. I'm excited to be here with you and share with you some of the things that we've been doing in the Windows world to make Windows a much more attractive platform for developers, including Java developers, but also including Node developers and Python developers and developers that are targeting apps and platforms and infrastructures that aren't necessarily Windows. We still want Windows to be a great place for you to hang out, to write your code, to debug your systems, and to deploy into production and test environments and so on. So I've got a lot to cover. I'm going to try and cover it as best I can. I'm going to take the risk of trying to demo stuff live. Hopefully the demo gods will be kind to me. We'll see. But fundamentally, we're here really talking about Java specifically. But the fundamental issue that a lot of people have when working on Windows is in setting up a development environment, getting the tools they need, getting everything installed correctly and configured correctly and so on. And then when you're building an application, if you're building an application, as we discussed just before the session, that needs to be deployed to Linux in the real world afterwards, it's often a bit of a headache if you're in the Windows world because your Windows file system looks very different to a Linux environment. And how do you, if you're a Windows developer, test your code and make sure it's working before you push it up into production and realize that you've got a path wrong, for example. So this is where Windows Subsystem for Linux comes in, and we'll have a quick spin through what WSL is, how it works, and how you might use it. And then at the very end of the session, I do have a couple of slides, one with a call to action and one with a resources slide with links to all of the repos that I mentioned in the session, as well as all of the Twitter handles of the people you might want to reach out to if you want to discuss some of this stuff further. So don't worry about trying to keep up with URLs and things as we're going through the demos. There'll be a slide for that later. Cool. So let's see how far we can get through this without running out of time. Conscious of time, let's get zooming. So if you've ever used Windows and tried to set up a development environment, you probably noticed that it's a little less optimal, especially if you're coming from the Linux world where you're used to apt installing everything, or from the Mac world where you're used to brew installing everything. In Windows, it's traditionally been a bit more of a hodgepodge process. It usually involves an awful lot of searching the web, looking for how do I install such and such a thing, how do I install Java, how do I install Eclipse, how do I install IDEA or whatever developer tools you prefer to use. And you sometimes have to search multiple pages, multiple sites, and then you usually end up at somewhere where it says, here's how you do this thing. And you go and read a bunch of manual steps, and then you go and manually download tools from wherever it is they say you should get them from, usually littered all over the place. You then run the installers, you go through the UX screen, you go through multiple pages of an installer tool, which then gets your tool onto your machine. This can require quite a lot of time and effort, a lot of manual processes. It's not something you can kick off generally, walk away, make a cup of coffee, come back, and your machine is ready to go. And it's also difficult to automate. It's difficult to deploy software at scale in a large team, for example, using manual processes like this. I've been on many a developer team in the past where the first thing you have to do is spend the first couple of days fighting through the partially written, mostly out-of-date documentation as to how you manually go and set up and configure your machine, which is a bit of a shame. And it's something you have to do on a per tool basis. Once you've installed Java, you then have to go and get your IDE. You then have to go and get linting tools and debuggers and everything else you might want. And if you then need to go and get Node and Python, this can take quite a lot of time. Now, we're very conscious of this, and we're very conscious of how the rest of the world works, because a lot of us also have Macs and Linux machines littering our office spaces, even at home here. And we believe that we can do a better way, that there is a better way of doing this. There's a better way of setting up a developer environment. We think that there's a way in which we can make it much faster and easier for you to set up an environment, to install tools from a variety of sources, but using common processes and common practices, and to make that process easily configurable, customizable, automatable. You can write scripts to do this. And of course, this is via the command line. We announced at Build last May. The Build conference that happens each May-ish timeframe is the big Microsoft developer conference. And we announced this thing called Winget. And Winget is for those who've used Brew, who've used apt on Ubuntu, or Zypper on SUSE, for example. Winget is essentially a command line tool that allows you to install applications. It automates the installation of traditional Windows installer packages and allows you to install all of those things from the command line quite easily. So let's spin back here to my virtual machine. And here we have, I'm running this in a VM, so hopefully everything works. Here we have Windows, standard Windows 10 build. There's nothing particularly magic here. And we have on the taskbar here a browser and my PowerShell script, PowerShell shell link, and the file explorer there. Let's fire up PowerShell just for a second. This is the legacy console. This is the traditional Windows command line user interface to your shell of choice. On Windows, by default, we ship CMD and we ship PowerShell. We strongly recommend that you use PowerShell moving forward. And I can use commands to navigate my command line. If I execute Winget, for example, Winget is now built into and shipped within Windows. It's shipped if you're running insider builds in particular. It's included in the insider builds. If you're not able to run Windows 10 insiders builds, you are actually able to sign up to be able to install Winget itself separately from the rest of the Windows insider stuff. So if you're on a standard build of Windows 10, you can actually go and install, get onto the Winget pre-release vehicle, so you can at least test Winget out if you'd like to. Alternatively, you can actually download the source code, build it yourself, and run it that way if you prefer. But as you can see here, the Winget command emits a bunch of text that helps you understand what you might be able to do with Winget. For example, what happens if I want a more advanced, more modern command line environment? Let's see if we can install Windows Terminal, which is the new next generation command line environment that we're building for Windows as we speak. So let's do Winget search Windows Terminal, and that will then go off, search the configured sources for Winget, and we'll come to what that means in just a second. And it will go and look for an application called Windows Terminal. As you can see here, it's returned 4 records. We have Windows Terminal that's available from Winget and from the Microsoft Store. Yes, we actually enable you to install applications, a select set of right now, but a select set of applications that don't require payment and so on from the Windows Store, and also from the Winget repo itself, which we'll take a look at in just a second. So in Winget here, I'm going to install Microsoft.Windows Terminal, and I'm going to specify to get it from Winget in this particular case. So I can say Winget install Microsoft Windows Terminal -s Winget -source Winget. Now when I run this, it's going to go and get the installer for Windows Terminal. It's going to download it onto my machine, as you can see with the colorful progress bar here. It's then going to run the installer just as if you had done those steps manually yourself. So where is Winget actually getting this information from? Well, let's take a look over here at the GitHub repo for the Winget packages repo, which is the repo that Winget is initially configured to look at in order to be able to download, find and download applications. let's see, it's taking a few seconds to come up. It's currently busy installing Windows Terminal in the background here, but I just wanted to briefly show you how simple it is to add your own packages or to request the addition of packages to the winget repo, should you wish to do so. If, for example, you stumble over a tool that you'd like to see included, all you've got to do is come to the repo and create a pull request to add to the manifests folder a manifest that describes the application, where it comes from, what its version is, and so on. And we'll very quickly take a look at the Windows terminal. If we scroll down here, there are currently over 1,000 packages that have been added since we unveiled this thing in May. I'll actually scroll down using the bar here because there's so many. And if we go to, in this particular case, we've just installed Microsoft Windows Terminal. If we look down here, we'll find Microsoft. And inside there, we should find the Windows Terminal package description. Windows Terminal. There's also Windows Terminal Preview if you like to live on the cutting edge of things. But as you can see, we've got all the package descriptions for each of the different builds of Windows Terminal so that you can install not just from a specific source, but also a specific build of Windows Terminal. And in this particular case, as you can see, we have the URL to where it's from, the SHA signatures, and so on. Every package that's added to the repo is checked against multiple antivirus package scanners and is also manually reviewed by the team before inclusion to make sure it's valid and consistent and it's coming from a repeatable source, and so on and so on. The team are hard at work in building out this repo with additional packages and also a bunch of enterprise-friendly features as well that enable you to go and create your own repo sources and configure multiple repo sources if you wish, so that you can deploy your tools to your employees and your team members much more easily. So if we quickly launch Windows Terminal now, 1 second. So this machine is chugging along. So that's the old prompt. Hopefully up here we have Windows Terminal that we've just installed. And if you click on Windows Terminal, you'll see that it's actually quite a bit different to the old legacy console that we've been using so far. It has a bunch of features. It's highly configurable, Windows Terminal. It allows you to have multiple profiles. And a profile is essentially, think of it as a connection to a shell, either a local shell or even a remote shell via SSH and the likes. You can use Windows Terminal to talk to WSL instances, and we'll come to what WSL is shortly as well, for those that haven't seen it. But you can create multiple tabs, and you can have those tabs running side by side. You can also connect to multiple different connections, as you can see here. And we'll come back to what those look like in just a second. But obviously from within here, let's close down the original old legacy console here. We'll put that back to sleep. I could also type, for example, winget search open JDK. What if I wanted to install, open JDK? What if I wanted to install an open JDK on Windows? Rather than having to go to search, to look for documents, to find out how to perform a bunch of manual steps, I can instead say, oh, let's go install the adopt OpenJDK. So I can specify the full ID here, or if I do winget install adopt OpenJDK .openJDK. Oh, I mistyped it. It's not going to let me. There you go. Just proof it's real code that when you type it in wrong, it doesn't automatically proceed assuming that you're correct. So here it's going to go and look up in the package repo for the package details, for the package manifest for adopt OpenJDK. It's going to find out where it goes and downloads the MSI from. This is just a standard Microsoft installer package. It's going to download that MSI to my machine, and it's then going to run that package using the pre-declared command line arguments so that I don't have to then go and walk through a 15-page installer sequence of installer pages to specify where everything goes and all the options. You can pass in arguments to the MSI installer and declare that as part of the manifest as well if you want to configure your machines using a preset set of settings and options and so on. So that's downloaded and installing now. It's taking a few seconds, so bear with me. But fundamentally, this is the same process now for all of these tools. If I want to go install VS Code, if I want to go and install Eclipse, if I want to go and install all your favorite tools, Node and Git and so on, now it's winget install Git, winget install Node.js, winget install all the things that you want to install. And if, as I said, if there are things that are missing that you'd like to see included in the default repo, then please go ahead, submit a PR. The team are very welcoming of new PRs and submissions of new packages. We also encourage you, if you're not a member of the team that creates the thing that you'd like to see in the package repo, also reach out to them and encourage them to automate the publishing of new versions of their packages to the winget repo by incorporating a small script into their CI/CD system, so that each time they push a new build out into the public release, then it automatically ends up pushing a new update to winget as well. You'll notice here, as we're going through this installation, it does ask me, we can't bypass UAC. It does ask me to accept the installation of this package, just as if I'd downloaded the MSI and double-clicked it myself. But fundamentally, this is exactly the same process. It's just automating the process. There's nothing new here. You don't have to build a whole new packaging format if you don't want to, et cetera, et cetera. The net result of this is that once this is complete, I should then, let me close off this other terminal, but I double-clicked by accident. I should then have Java installed on this VM. That then will allow me to execute Java code and to build Java applications on Windows with relatively little effort compared to how I might have done so in the past. So here, for example, is some Java code. We'll come back to this Java code in just a minute. This VM is really struggling. I think my poor machine is struggling to stream video as well as run a VM. I need a bigger machine. I shall have a chat with my boss about that after this session. But this is very, very simple code. It's just a quick little hello world. I'm not going to teach you guys how to write hello world in Java because I'm pretty sure you're far more expert than I am in these things. But this is standard Java code, which once Java has installed on my machine, I'll be able to run. We'll come back to that and see that in just a minute. I just want to proceed with a couple more slides. Okay, cool. So let's come back to the slides for a second. So we've just seen how we can install, we've just installed Windows Terminal and we've just installed the OpenJDK pretty easily and pretty consistently. I haven't had to go and do a bunch of manual searching and reading of documentation and downloading of random tools from random places, allowing me to set up my environment much more quickly than if I'd have done this manually using traditional methods. Now, I've mentioned this thing called WSL as well. If you're building Java applications for Windows that you aim to target and deploy on Windows, then clearly it makes sense for you to remain in Windows and build your applications using the Windows toolset, the Windows SDKs and JDKs and IDEs and so on. However, if you're planning on building something that you're later going to deploy to a Linux environment, then wouldn't it be great if you could run that Linux workload in a Linux environment on your Windows machine without having to dual boot and without having to have the explicit boundary of a hard VM boundary and run a VM on your machine and then switch back and forth between these environments? Wouldn't it be great if you could actually run these things side by side simultaneously? So one of the things that we released back in 2016, I actually came back to Microsoft after a 6-year sabbatical in the real world. I came back to Microsoft to work on the new Windows subsystem for Linux and to help overhaul and create the Windows terminal as well. I could not have been more excited to do so because this really does change everything. If you're building applications that target Linux, you really need a Linux environment to work in. And until this came along, until WSL came along, your only option on Windows was either to dual boot or to run a VM, which are typically and traditionally fairly resource hungry. But Windows Subsystem for Linux is a mechanism that we built into Windows. WSL v1 was originally an attempt to essentially duplicate the syscall layer of Linux so that Linux binaries, unmodified binaries, can run on top of Windows. And WSL2 that we announced last May is a new version of WSL that uses a very lightweight VM, but has really strong integration systems between Windows and the Linux machines that you run in that VM. And you can run multiple Linux distros on top of these things at the same time as well, so that you can run a real Linux environment alongside your Windows environment. Now, enabling WSL in the past has been a bit of an effort, because you had to go and find a particular dialog box, click this button, which then enabled WSL, and you then had to reboot and so on. It involved several manual steps, which we decided to replace with the simple command of WSL -- install. And we've just announced this morning that when you use WSL -- install, we will also put Ubuntu on your machine to give you a starting point of at least having one distro on your machine, so that you don't then have to go to the Windows Store and find a distro and download it before you can actually get running. So WSL -- install is currently available in Windows 10 Insider builds, and once you run it, you will need to do a reboot if you don't have Hyper-V installed already, because it does need to enable the hypervisor platform. But fundamentally, you just run WSL install, quick reboot, and then from then on in, you're able to run Linux environments alongside your Windows environments very quickly and effectively. So this takes a process that used to take some people 10, 15 minutes to figure out how to do, and it's turned it into a 3-second operation plus a quick reboot, and so on. So WSL, as I mentioned, allows you to run unmodified Linux binaries on Windows, and allows you to interop between Windows and between Linux fairly smoothly. As you can see here in the screenshot, we've added a Linux logo icon to the File Explorer, so that you can see a list of the distros that you have installed on your machine, and you can then click on the distro and navigate its file system from Windows. You can even invoke Linux applications from Windows if you wish, and you can go both ways. So from within WSL, you can see your Windows file system and you can invoke Windows applications. From Windows, you can see your Linux file system and invoke Linux applications. Let's take a very quick look at that. Let me switch back over here. And so as we saw, we now have the adopt OpenJDK is installed. Just to prove that, I will go to the folder that we saw earlier in File Explorer. Here's my Java code, and I shall type Java, hello.java. And when it executes, we'll see hello world quite quick. Oh, I'm sorry. I have to restart this terminal, of course, because the path has been modified and the terminal started before the path is modified. So let's reopen terminal. Boom, boom, boom. This poor machine is chugging. I definitely need a better machine. Okay. So if I type Java -version, we should see that Java is installed. Hooray! And we go back to dev, hello, and we type Java, hello.java, and we see hello world being emitted in just a second when the machine catches up. Let's close this. There we go. Hello world. Fantastic. On a normal machine, this would happen much more quickly, but there we are. One of the things I mentioned as well, very briefly, when we first installed Terminal was, Terminal supports multiple profiles. Here you can see we have the traditional command prompt. We have Windows PowerShell, which is the version of PowerShell traditionally built into Windows, and also PowerShell 7, which is previously known as PowerShell Core, that is also available on Linux and Mac as well, which we're actually using here. So you should be able to access that as well. And so once you install WSL, we should also be able to see the Ubuntu shell pop up here as well. For some reason, that's not showing up. So let's very quickly see why. Oh, this machine is really chugging. What I will do instead, actually, because this is struggling and we're running out of time, I will very quickly open up Ubuntu and open up PowerShell side by side on the same machine. Okay. Now, as I mentioned, from Windows, we can see the Linux file system, and from Linux, we can see the Windows file system. Here, for example, is my file explorer looking into my Linux distros. It sees my Ubuntu 2004 install here, which is running in WSL, and here we can see the Linux file system. If I go to Home, you'll see my username within the Linux environment, and that will be Rich, and underneath there is my home folder with any files that I happen to have created, as we can see. Great. So I can, for example, also, let's do this. Let's do WSL. If I type WSL, I can see all of the commands that are available to me. So WSL emits all of the command line arguments, if you don't specify any, that allow you to control, to shut down, to start up, and to mount drives and all kinds of things. I can also say, oh, let's do this. Oh, this is so slow. Bruno, if you're watching, I definitely need you to back me up when I ask for a new machine. The Fortune tool is a command line tool that emits a message of the day on Linux. It's not available on Windows, so this is actually going to run Fortune in WSL, and it's going to pipe the output of Fortune into Cowsay, because that's kind of fun. And we're also going to pipe that through lolcat, which is a command line tool, which colors the output of the text being passed into it. So this essentially is passing these commands from Windows into Linux, into WSL, and it will come back in just a second with a Fortune message that is colored and it's actually been rendered by Linux and streamed back into Windows. And similarly here, I can, for example, in WSL, open up notepad.exe, proving that WSL is able to spawn a request for a Windows executable to be executed from WSL, which is cool. And I can also, if I look at my WSL distro here I am in Ubuntu. You can tell by the orange logo. If I look at the MNT folder on WSL, I have a C folder. If I look at Mount Wax C, here's my Windows file system. Here's program files, here's users and Windows and so on. And so if I have files that live in Windows, I can access them from WSL. If I have files in WSL, I can access them from Windows. I can switch back and forth. And importantly, tools like, for example, VS Code have been built specifically to handle environments just like this, where I can run my UI in Windows, the UI portion of VS Code in Windows, and it talks to a backend engine that can run wherever it needs to run. Normally, when you're running VS Code on Windows, it's running the UI and the engine in Windows itself. But using WSL, the WSL remote extensions for VS Code, it can run the UI in Windows that talks to an instance of the VS Code engine executing within WSL, allowing you to debug using GDB and have a pretty seamless experience. It feels just like you're coding on Linux against Linux itself, which is pretty cool. We have just seen, very slowly, admittedly, so apologies for the state of my machine, but we've seen that we can execute code in Windows execute commands in Windows that actually invoke inside WSL, and from WSL invoking Windows binaries, we've seen that we can reach back and forth between the file systems. And we also announced in May that we're working on 2 cool new features for WSL moving forward. One of which is the ability to run Linux GUI apps in WSL, but have them project into Windows, kind of like the way that Parallels allows you to display Windows applications on your Mac alongside your Mac apps. We're doing a similar thing in Windows where you'll be able to run GIMP or IDEA or Eclipse or whatever running in WSL, but drawing on Windows essentially, which is really, really cool stuff. That's about to start hitting previews very soon. Windows 10 Insider preview builds, and obviously we're aiming to ship it in the next version of Windows next year. And we're also working on exposing your GPUs to the GPUs on your machine to your WSL instances as well. So if you're running TensorFlow workloads, for example, you'll be able to run those in WSL, being GPU accelerated within the WSL environment as well. In fact, we've actually gone one step further, and we're actually exposing your GPUs via direct compute, using DirectML, which is an aspect or a part of the DirectX platform. And it essentially abstracts the GPU from device specifics. This actually allows you to run TensorFlow workloads on Intel and AMD and NVIDIA, of course, chipsets, making WSL quite a powerful platform for you to employ on your various hardware devices. So we're pretty much up to time. Thank you for sticking with me. Sorry for how slow some of these demos have been. I'm definitely going to go and get a new machine now. But we do encourage you to please try Winget. Let us know if there are things missing that you would like to see. If you can submit a PR, that's even better. We'd love to hear from you. And we'd also love to hear from you if you try out Windows Terminal and WSL and PowerShell and VS Code and PowerToys and many of the other great tools that we're building specifically to make Windows more useful, more productive, and more fun to use for developers. Here's a bunch of resources of repos you might want to go and explore. And if you'd like to keep up with the latest and greatest in this area, in the command line area in particular, anything to do with the command line from Winget through WSL and Terminal, then please subscribe to our blog and visit our blog on a regular basis. And if you have any questions or anything you'd like to bounce off us, there's a bunch of us here. You can see all of our Twitter handles here that we'd encourage you to reach out to us on Twitter. A bunch of us hang out way too much there all day long. And we can't wait to hear from you and help answer questions and help steer you onto a good path, or hopefully identify areas where we might need to improve things. With that, let me leave that one up. Back to you, Bruno. Sorry for taking so long.
No, that was okay. That was okay. We have Jonathan straight from New Zealand. And because Jonathan is in the future, I'm sure he can restore some of the time. Jonathan, where are you?
The bending effects of being on the other side of the planet, right?
Exactly.
Hello. How's it going?
Good to see you, Jonathan. I hope you can. I hope you can go back in the future and get some of that time that Rich got, because he had so much to show, and that was totally worth it. Thank you so much, Rich, for sharing that. As I said before, I'm a Mac user. I don't know why, but I'm a Mac user because Microsoft allows me to. I know Jonathan is,
Optimize for happiness, right?
Yeah, Jonathan is also a Mac user. Is that right, Jonathan?
Yep. Although I do look jealously at what Windows subsystem allows. I do want to go back to Windows to try it out.
Yeah, there is a game that I want to play called Among Us, and it only works on Windows. It doesn't work on Mac. So I think I'm going to switch back to Windows just because I can play that game. And then I'll go back to Windows Subsystem for Linux or my work stuff.
Absolutely. Well, we look forward to hearing from both of you. If you find things that you wish it would do or wish it wouldn't do, let us know. We can't wait to hear.
Yeah, no, that was great. Wonderful. Thank you so much, Rich. You have a wonderful rest of the week. See you, buddy. See you, buddy. All right, Jonathan. That's it. No more time left to talk. So just take it over from here. Thanks, man.
Awesome. Hi, everyone. Thank you so much for coming along today. My name is Jonathan Giles, and I'm going to be talking to you today about Java API design best practices. I'm a principal Java architect at Microsoft. Basically means my team is responsible for building out the Azure SDKs. We want to connect to all of the Azure services and provide a really good developer experience for all Java developers. We want it to be an idiomatic experience so that it feels like it's been designed by Java developers for Java developers. If you have anything to say, feel free to reach out to me at jonathan.giles@microsoft.com or at Jonathan Giles. It's important to note that this presentation is about Java API design in terms of client libraries as opposed to RESTful web services. We're not going to be talking about HTTP gets and puts and posts. That's someone else's job. My job's about the API design where we build client libraries with public classes, interfaces, and that kind of thing. Now, this is normally a talk I give over a couple of hours. It's been condensed into 25 minutes. I'll try my best to cover as much as I can in that time. We will go fast, and hopefully there is some use for you in this. So just very, very briefly on who I am. I've been an API designer for a very long time now. I worked at Sun Microsystems and Oracle on the JDK. I worked in the JavaFX team where we built the UI controls that were part of JavaFX. So I did a lot of API design for the tables and the lists and those kind of UI controls. And then I would obviously build the implementation for those types as well. Like I said, nowadays I'm the architect for the Azure SDKs here at Microsoft. And more generally, my passion is about developer experience. I want to make sure that developers have a really good experience when they're using client libraries. So there's so much more to it than just API. There's documentation and samples and GitHub repositories, and basically anything that's going to create a friction that prevents a developer from using our libraries is something that I care about. And just very, very briefly, I'm fortunate enough to have been recognized as a Java champion, a Duke's Choice Award winner for my open source contributions, and a Java 1 Rockstar. If you haven't read this book, I highly recommend everyone to read it. If you haven't read the third edition of this book, I recommend that you get the third edition and read that, because a lot of what I'm saying today is common knowledge. It's kind of just kind of obvious. It's about developing a gut feel. And this book codifies all those gut feelings into a really good set of tips for all Java developers. So grab the third edition and make sure you just read it front to back and keep it on your desk. My one's right next to me on my desk all the time. So what is API design? Like I said at the beginning, we're talking about API design in the sense of Java classes, types, enumerations, that kind of thing. So the metaphor I like to use sometimes is that it's like a sandpit. And we've turned up to the sandpit and we have a completely blank slate, just like when we turn up to our IDE at the start of the day and there's an empty screen. And in the sandpit, it's our job as the first person arriving to create the interactions for the other children to play with, or in the case of API, the other developers to use. And we're going to create the sandcastles and the rivers and the ponds and the bridges and everything. And how that's implemented under the hood is our concern. It's the interactions that the other people get to encounter that is the API that we're caring about. And so to kind of put it in a slightly more concrete way, API is what a developer uses to achieve some task. It abstracts over an implementation, allowing them to work at a higher level of abstraction. And it's really important to note that API design isn't some level on a career ladder that you get to after, junior, senior API designer. I like to say everyone's an API designer, just by the fact that we are all writing public API that has public interactions that other people may use. It doesn't matter if the API has been designed just for your own use, for your team's use, for an open source project, or for a huge open source project like Azure SDK or the JDK. We're all API designers, and we should take some degree of care in our API design so that users get a really good experience out of it. So what I'm going to spend the rest of this talk speaking about is just a few API characteristics. I'm going to talk about the importance of it being understandable, well-documented, consistent, fit for purpose, restrained. I don't have time to talk about evolvable. I've cut that one out already. So what does it mean for an API to be understandable? I like to kind of talk about the front door. Imagine the front door of your house. Imagine someone turning up to your house and there not being a front door. How do they get into your house? It's the same with API, right? We want people to be able to walk up to our API and understand where the front door is. What's the first class that they should interact with? And we want to think about it in the sense that we don't want developers to have to go to Google, to go to Stack Overflow or Javadoc or anywhere else. We would love it if they would find the front door just through naming conventions. And so that's something that we do really heavily on the Azure SDK for Java team, is that we've got naming conventions that encourage people to try these types as potential front doors. Everything that interacts with an Azure service is called a client. To create a client, you have Client Builder. So we've got these naming conventions that encourage users to get started and find the front door. And it's our hope that by doing that, they're not going to give up and go to a starter library. And so consistency is really, really critical. It's we don't want to surprise our users. And we're going to talk about a whole bunch of different ways that we can have consistency in our API. And the reason why we want consistency is because developers aren't consuming all of our APIs at once. They're going to consume a little bit to start with, and then more and more as their needs arise. And in the Azure SDK team, we've got an even bigger argument for consistency because we don't have one library for all of Azure. We've got a library for each service of Azure. So we have a Key Vault library, a storage library, a Cosmos library, an Event Hubs library. And what we want is for a developer who's familiar with the library for one of these services to be able to pick up another library for another service and it feel like it's been designed by the same people with the same design patterns, the same philosophies behind it. So one thing my team does is that we have a really long guidelines document that specifies all the rules that we have when building libraries to be consistent. And I'm going to list just a few of the consistency rules that you should consider when you're building your own client libraries over the next few slides. So there's nothing worse than when you're a consumer of a library having that return different types. Imagine if you had a library return list, collection, iterable, stream, whenever you have some kind of collection to return. You'd have to write code to handle each of these types differently. And that's going to result in users being disappointed in you for having them write a whole bunch of code that they wouldn't have to do if you were just consistent in your return types. Choose the right type for the right case, but if possible, be consistent as much as possible. Keep the minimal set of return types is basically what I'm saying. And similarly, if you have a API that's, if you've got API that returns string, for example, and you document in all cases it's going to return non-null, so it's going to return like an empty string instead. And in some cases you return null by accident, you're going to turn your user off. You're going to make them never trust you again. They're always going to be defensive and start null checking in all cases. So it's really important when we document we won't return nulls for a particular type that we are very consistent in doing that. And just speaking briefly about null pointer exceptions and returning something other than a null, there's a few options we have in Java to avoid this situation. For example, instead of returning a null string, we could return an empty string. The collections types, list, set, map, iterator, all have API in the collections class to return an empty list, an empty map, an empty set. We should definitely use those rather than just returning a null, because the user's just going to get an empty collection that they'll iterate over. There's nothing in it, so it's basically a great big no-op. Stream has stream.empty. Arrays, we can just return an empty zero-length array. And JDK 8 introduced the concept of an optional. An optional is a really good choice that you might use for returning things that may or may not be null that you want the user to be defensive about without necessarily running it into null exceptions. So you wouldn't believe how much effort goes into method naming and type naming inside the Azure SDK team here at Microsoft, as well as when I was at Sun and Oracle previously. We would really agonize over the names of each individual class, method, interface, you name it. We would sit around our meetings and just make sure that we've got the right name for the right situation. And there's a lot of effort that goes into establishing a vocabulary that enables us to be consistent across all of our libraries. And it's not just for the types, it's for everything. Method names, arguments, constants. We should have naming conventions for everything. And there's all kinds of choices we could make. We could be Java bean or not Java bean. We could have fluent APIs or not fluent. We could have builders or not builders. And there's no particularly right or wrong answer. Main thing is to be consistent. Often you look at libraries today and they're kind of a mishmash of a lot of different naming and design patterns. And it just leads to a great deal of confusion for the end user. And so names like .of or .value of, to XYZ, .from, all of them are totally fine as long as they are used consistently and the user can understand and they can intuit why the name is the way it is. Because when they come to another class and they're looking for a similar piece of functionality, they're going to try the same patterns that they've used previously. So carrying on, one more slide about consistency is argument order. It's so frustrating when you're a user of an API and you have multiple method overloads where the argument order switches around between the overloads. This is not only frustrating for the user because they have to start finding the right place to put the right arguments. It can actually be a really big error situation because sometimes the types might be the same, but they'll be going into the wrong parameter position, and the code will continue to compile, but it won't operate as expected. And one thing that we've started doing a lot in the Azure SDK team is introducing what we call option types, but I've called them argument objects here. The problem that exists in especially web services is that web services tends to get more functionality as time goes on. And the way the functionality is exposed through client API is to add more and more arguments into a method or have many more overloads. You start getting this telescoping of overloads as more and more added. And what we don't want to have is a cognitive burden on the user where they're presented with 3 or 4 or 5 or 6 or 7, a huge number of method calls. So instead what we do is we have these option types or argument objects which take all of the parameters that are known about today that could go into that web service call, and then we've got a class specifically for those parameters. As the web service or whatever causes us to have more arguments, we add them into that argument object rather than into the method call itself. This allows us to grow the argument object over time without having this cognitive burden on the end user to see so many more APIs coming up in our clients' top-level APIs. So just very, very briefly, fit for purpose, I've only just got this one slide because it's pretty obvious. When you build an API, we have to know who we're building it for and who our user is. So I like to talk about the new datetime API that came in Java 8. We could have built an API new datetime that was extremely complex, that was perfect for space, state, time, kinds of esoteric use cases. But that's not really the datetime API that Java developers like you and I want to have. We want a much simpler API. So Java was right in creating a simpler API rather than a complex API. So we have to know who our users are, and we have to design our APIs to hit the right level of user. So perhaps my favorite topic on API design is just the importance of being restrained. And I've got this tweet that I'll read out. It's from 2018 by Scott Bollinger, who says, "At this point in my career, I understand that a feature that only takes a few hours to build can create hundreds of hours of support and maintenance in the future. Just because it's easy to build doesn't mean you should add it to your product." And so I'm going to spend a few slides talking about this because it's really important that we don't just add API for the sake of adding API. That's something that we do when we first start building APIs, thinking that we're helping users, but really we could be doing the opposite. The problem is that when we add APIs, there's we have two problems. We introduce cognitive overload to the user. Like I've said before, every piece of API is something that the user sees when their IDE pops up, their IntelliSense pop up, that shows all of the available API. That's problem number one. Problem number two is that we have to continue to maintain it, document it, test it, and so on. The way I kind of think of it is we have to pay rent. All of these APIs have to pay their rent for the amount of land that they take up inside our API. So every API designer should ask themselves, do I really need this API? Is this something that's actually critical for my user, or offering so much convenience that it's going to pay for itself? It's going to pay the rent that it has to pay. Because it's so easy to say, and I'm guilty of this too, it's so easy to say, I'm going to save the user writing 4 lines of code by giving them this one piece of API. And that's sometimes the most fertile ground for regrets. Later on, once you've shipped your API and you can no longer take that API away, these are the places that you might just regret because maybe it's not been as well considered as the main API. And so sometimes you regret adding these things once it's too late. And so you always have to ask yourself, does adding this increase the burden on me as the API designer? Having said all of this, though, it's important to note, I'm not saying don't have convenience API. Convenience API is actually really, really good when it's well justified. So 2 examples I've just picked out. List.of in the JDK 9 or so is a really great way to create a list. You just throw in a var args and a list is returned. List.add is an instance method that lets you add an element into a list without specifying the index where it should go, which is obviously a really good use case because most people don't care about where it goes in the list. They just want it in the list. And so these kind of convenience APIs save the developer a huge amount of pain, and it also saves them from potentially introducing errors. We could have an index out of bounds exception, for example, with the list.add if we passed in a bad index. So what I'm saying is API design isn't a science, it's an art, and there's a lot of gut feeling that we have to work through to understand what's the right level of convenience that we should add to our APIs. Going further about restraint, we have a few keywords in Java that are really useful. The first one is final. I tell everyone that I work with, we should make all of our types final until such time that we are convinced that they should be made non-final. Final is the keyword that prevents subclassing of a type. It enables us to retain control until we are ready to say that subclasses are allowed. Coming up soon in a future release of Java is the sealed keyword, which is kind of like final, and it prevents subclassing. Sealed is only different in the fact that you specify which types are allowed to subclass it. So that's an interesting API designers tool in the future. It goes without saying, private modifiers should be used extensively. We don't want everything to be public, and we only increase the visibility of methods if they need to be made public. And I've always been very wary of the protected keyword. Protected is I tend to think of it as a virus. If you don't design your class with protected in mind, what tends to happen is the user will subclass your type. They will override the protected method, and they'll say, actually, I really need this particular functionality to be protected too, and then this particular piece of functionality to be protected too, until your API is kind of not really what you wanted it to be in the first place. You've made these changes to your API because it wasn't designed up front to be subclassable. So it's really important, if you do think that you want to be subclassable, to make sure that you write subclasses that actually test that out, to make sure the functionality that you think you're enabling is actually enabled. So another area that I'm really big on is the split between implementation packages and public API. Implementation classes are classes that are used to implement our API. We don't want users to use it. We just expect that to be somewhere in our library that the users can't get to. Prior to Java 9, there was no way to limit access to particular packages. Obviously, with Java 9 and later, there are now modules, so we have the ability to not export particular packages. It's really important, though, to have tooling that checks against your leaking of implementation classes through your public API. So in the Azure SDK team, we've got check style rules that validate that any return type or any argument into public API is not something that exists inside an implementation package. We also have our Javadoc tooling not generate the Javadoc for any of the implementation code. And we've got two choices on how we do this. We can either have an implementation package, which is really nice with the JDK9 modules, or even better than that, we could just have package private classes inside our public API. These package private classes can't be accessed by any class outside of that package. So either way, we're doing the best we can with the constraints that Java gives us to separate our API from implementation. The same goes with external dependencies. Just like implementation leaks are bad, we don't want to have external dependency leaks if we can help it. If we have an external dependency on an Apache library or any other library, we have to think really hard about whether we expose that through our public APIs, because once we do that, that becomes part of our public API surface area. And we have to be careful that these external dependencies have the same breaking change policies, support policies that we have, or else the burden falls on us to make sure that we can support these external libraries as well. And one option that we have is to wrap these external dependencies in the type that we've created so that we can change the dependency under the hood and still maintain the same functionality to the user. So a lot of this boils down to eating your own dog food, as the saying goes. We've got to have developer empathy. We've got to see the problem domain from the user's eyes and make sure that we're not solving problems that we like to solve as computer scientists, but rather solve the problems that our users have in wanting to use our APIs. It's very easy to get carried away when we're building an API to do cool things rather than the right thing. So we have to write sample code, discuss it with real users. At Microsoft, we do user experience studies every week with our Azure SDKs, where we're asking real world users, what do you think of these APIs? Please perform these tasks for us and tell us, was it good or bad for you? We have UX labs doing this just day in, day out. And when we write our own sample code and when we ask our users to write sample code, we want to make sure that we're checking for unclear intentions, duplicate or redundant code, or whether the abstraction that we've done is at the right level. I'm just going to briefly talk about documentation. I'm a huge fan of JavaDoc. I want that to be the first port of call for all users. I want them to have a really great JavaDoc experience. I want people who are writing JavaDoc to use all the annotations that JavaDoc supports, the Cs, the synths, the link, all of those make for a richer JavaDoc experience. And I love seeing JavaDoc that has code snippets in it. I would love if all users of my library would go to JavaDoc before they went anywhere else. And this is some JavaDoc I wrote a very long time ago now. This is what I like to see, just a page full of really good explanation text. There's also a really good way to review API. So getting into the habit of generating the HTML output and reviewing it is just a really good thing to do, because when we're looking at JavaDoc, we're seeing the API through a different lens. We're not looking in our IDE anymore, interspersed with a whole bunch of implementation code. We're just seeing the API. So we can look for things that don't feel right. We can look for poorly formatted JavaDoc or API that's actually not intended to be API. Just briefly, back when I was working on the JDK itself, don't include negative examples in your code. Those are examples that say don't do this, because what we've got these days is a generation of Stack Overflow users who just find the first snippet of code and they copy and paste it, and then they'll file bug reports on you. So just a very brief example, I wrote this JavaDoc a long time ago and said a warning about inserting nodes into the combo box under the list. This is strongly not recommended. Rather than the following code, you should do the following. The number of bug reports I got on that first snippet of code made me realize negative code samples are not a good practice to ever have. And never have a partial code sample either, because developers aren't going to discern whether it's a partial or a complete code sample. They're just going to find the first block of code and copy and paste it. Always just have a complete code sample. So our goal is to get everyone moving in the same direction. That's us and as a team of library developers. And we should have a clear understanding of the language that we want to convey to the users, the functionality that we want to expose, and yeah, we don't want it to feel like it was developed by a bunch of different minds. We want it to feel like it was one collective that built it all. And like I said, it's not a science; it's an art. There is no magical process to API design, and it becomes easier with practice. I don't think in the last 23 odd minutes I've given you any real useful guidance, but it's just one of those things that you hone over time. So I just want to finish up very briefly with a few useful links. I've spoken a lot about what my team does, the Azure SDKs for Java. This is the GitHub repository at aka.ms/Java SDK. This is our GitHub repository where we are building the next generation of Azure SDKs. I highly recommend everyone to try them out. I would love to hear feedback from all of you, because we've put our hearts and soul into these libraries and they are state of the art. To help you make use of those libraries, I know Azure has a free tier. There's a bunch of credit, a lot of stuff free for 12 months, and a lot of stuff that's free forever. So check out that free tier for Azure. Like I said at the beginning, this is a presentation that I've given a few times in the past. Normally I have an hour or more to present it. I talk about a whole bunch of practical guidance in those presentations, which I just couldn't cover in the 25 minutes today. I've got aka.ms/Java API design that just takes you to my website where there's longer form videos. And also in the same place, Microsoft sponsored a dzone ref card, which I wrote a few years ago, which boils down a whole bunch of my guidance in the form of a really nicely formatted dzone ref card. So with that, thanks. Like I said, I would love to hear from you. If you've got any feedback or questions or comments, jonathan.giles@microsoft.com or on Twitter @JonathanGiles. So thanks.
I've been speaking on mute, of course. Thank you so much, Jonathan, for the presentation. I've seen your talk perhaps too many times because you've been sharing this content so passionately over the years, and the ref card was a great asset that we put out there that really nails, here are the top X things that you gotta focus on, and for anybody who wants to go deep, they can go to your full-length talk and all the good stuff that you have. So definitely thank you for sharing in this condensed time frame the most important things.
It was an interesting challenge to boil down to 25 minutes.
Yeah, that's for sure. I would like to invite our next speaker, Edson Yanaga. Edson, are you there?
I am.
All right.
Hello, Bruno. Hello, Jonathan.
Hello.
Hi, Edson. Welcome to JDConf. I just want to ask you if you have one question to Jonathan about Java API design.
Well, I just caught here. I learned a lot. Well, I've seen this presentation in the past, but it has been quite some time. But I really love the way that you exposed it, like the way that should be the methods, the internal implementation. So I don't have a question per se, but I'd say that it was a very nice content.
I was trying to think the last time Edson and I caught up in person, and I remembered it was at DevOps Poland, 2018.
It could be, yeah. We were eating some duck, roasted duck. Yeah. I think that was it.
We were either eating some lunch or having some breakfast or walking around the conference, something like that.
Yeah.
We do have one question, Jonathan, just before you go. The question is how to deal with Java API design for non-English speakers.
That's an interesting question. I'm not sure what the question's asking. I might have to go. I'll go into the chat and I'll try to clarify. How about that?
So how about you tweet the answer and elaborate? Think about it and elaborate over Twitter. So for folks that are on the live stream, check out Jonathan Giles on Twitter, and he will think about it. It is a very intense question. You know, I'm not a native English speaker, so and I've seen libraries in the past in Brazil where people would use Portuguese verbs and nouns in the Java API, and it was awkward. So that's an interesting topic to think about for sure. So Jonathan, thank you so much. You have a wonderful week, man.
Thanks. Catch you later.
All right, Edson, over to you on Quarkus and OpenShift and Visual Studio Code and all the good stuff that you can bring.
Awesome. Thank you, Bruno. Well, it's a very nice opportunity to say that the world has changed. We have a Java conference provided by Microsoft, and we have Red Hat speaking here. And today is such a joy to be here because I'll be talking about some of my favorite projects. I'll be talking about VS Code. I'll be talking about the Java plugin for VS Code, the Quarkus plugin for VS Code. I'll be talking about Azure, Red Hat OpenShift, and Quarkus. Can't get better than that. So thank you very much for coming. We'll be discussing all of these subjects, and just to introduce myself better, some fun facts about me. I'm a Japanese Brazilian. I was born and raised in Brazil, but all of my grandparents are Japanese. That's a lot of people wonder, do we have Japanese people in Brazil? Yes, we do. And they look almost like me. They're nicer, but well, that's what we got today. I'm also a Java champion and a Microsoft MVP, the JDConf rockstar, and my Twitter handle you can see in the top of the screen is @Yanaga. And I talk a lot about Java, DevOps, microservices, Kubernetes, Azure, of course, Quarkus. So that's a hint. Maybe you should be following me because I share a lot of content that should be interesting to you if you're watching this session. But enough of slides because this session is all about sparking joy, and this is a live code session. So let's move to the other screen that I have here today. So what we're going to try to do, we're going to create a new project using VS Code, and I want to deploy it on Azure, in particular on the Azure Red Hat OpenShift service. So if you just Google these names, you just search for these names, you can Bing these names too. You can go to Azure Red Hat OpenShift. And if you ever try to deploy a Kubernetes or a cluster, or try to deploy an AKS service or go to any other provider, you know it can be quite complicated. And I was surprised by how easy it was for me to deploy an OpenShift cluster on Azure. And if you go through the docs here, you will be redirected to this particular page. There are some commands that you just have to copy and paste. The most complicated one is the one that you have to log into your Azure account. So I hope that you'll be able to figure it out by yourself. And you just enable some things which I had enabled beforehand in my accounts. And there's also a lot of optional steps. To be honest with you, I didn't run any of them. I just copy paste. I went straight to the point. What is the stuff that I have to copy paste and make it work? So I just copy pasted these commands, and it might take some time. Yesterday I was provisioning this cluster and took me approximately 35 minutes. So after 35 minutes, you will have your OpenShift cluster running on Azure Red Hat OpenShift service. And the nice thing about this cluster is that it's jointly managed by both Microsoft and Red Hat. So you have any issues with your cluster, with any workload that is running over there, you don't have to wonder, oh, do I have to ask Red Hat or do I have to ask Microsoft? No, you just open a ticket with Azure, and doesn't matter, we'll figure out how to make it work even better for you. So this is the command. You can click here, connect to your Azure Red Hat OpenShift cluster, because you will need those credentials. But luckily for me, I authenticated before. So here I have my Azure Red Hat OpenShift console running on the Azure platform. And if you go to the Azure console, you'll be able to see here, I go to the home, you can see the Azure services, you can see the OpenShift clusters here. And I have one cluster which is running since yesterday. I have my resource group, but if you're an Azure user, you're used to it. So what can we do with VS Code and Quarkus to quickly deploy an amazing service to this OpenShift cluster running on Azure? And again, Azure Red Hat OpenShift service. Internally at Red Hat, we call it ARO, but you can call it whatever you want. You just be sure to know that it's Azure and it's Red Hat OpenShift running on Azure. So I'll switch here to my VS Code. So let's see, I already installed, actually let me show you here. I have some extensions here on my VS Code. I can show here that I already have the Quarkus extension installed. I also have the Java. There are some Java extensions available, and I'm using the language support for Java provided by Red Hat. At least that's the one I'm using. So the Quarkus and Java extension, these are the ones that I'm going to use for this particular project. So if I type here Ctrl-Shift-P, I'll be able to open and to trigger some actions. And the ones I want to use today is the Quarkus Generate Quarkus project. So I click here and it's invoking, so it might take some time. Yes, first pick a build to. I'm a Maven person because I've been known for bad choices. So I use Maven, but if you want, you can use Gradle too. And I need to type, this is the only boring part of the presentation. I need to type the group ID, which is going to be today com Red Hat developers. I need to type the artifact ID. Let me switch here. I'm going to type Spark Joy. And the version 100 snapshot, you can choose whatever you want. And the package name that I want to be created within my project. And the example resource that I want to be generated. Let's create a REST endpoint called hello resource. And that's all. I think I'm done. Added the JAX-RS extension, which will allow me to create REST endpoints. Hit enter, and now my project is ready to be created. It's asking where do I want to create that. Generate here in my default folder, and yes, my project is already open. Amazing, isn't it? I think it was super easy for me to generate my very first Quarkus project. So as you can see here, we generated some example resources, some example files. One of them is this hello world /resteasy/hello. And how do we run this Quarkus application? And this is where the part of the magic begins. So I'm going to switch back here to my terminal. I'm going to enter this new project that I just created, Spark Joy. And I'm going to type the magic words now. Let me make it bigger just in case you want to see. I'm here on the screen. The bigger the better, right? And MVN Quarkus :dev. This is going to start Quarkus in development mode. In this mode, Quarkus is going to listen for changes in the file system, and whenever I send a new request to my Quarkus application, Quarkus is going to restart, which means it's going to recompile all the dependencies. If you change it or pond.xml, Quarkus is going to download the dependencies, add to your project, and restart. So it's not really magic behind the scenes, it's just that Quarkus is so fast that you won't be even notice that this restart is happening. Okay, go back here. I have this hello world endpoint. Let me go back here to my browser and send a localhost 8080. And yes, my new cloud native application is ready. And let's see if my hello world endpoint is running. Rest easy/hello. And yes, hello is working. You can see it happening. So let me try to do some live coding here. Suppose that I don't want this hello endpoint to be returned because it's just boring. I could be returning, instead of hello, since I'm Brazilian, I'm going to return olá, which is hello in Portuguese. So I just save the file, go back here to my browser, hit a refresh, and you can see that the reply is automatically there. And how long did Quarkus take to restart? Quarkus this time took only, let me try to find the number here. Quarkus took, oh, it's too wide the screen. Yes, now I can see it. Quarkus took 600 milliseconds to restart, but that's just because I'm doing a live stream today and my CPU is overwhelmed. But in a good day on my machine, usually Quarkus takes approximately 100 milliseconds to restart. So with Quarkus, we're not talking about minutes, we're not talking about seconds. With Quarkus, we're talking about milliseconds. And the joy of developing Quarkus applications is so big that I was developing some Node.js and JavaScript applications the past few weeks, and I can tell you that I've been spoiled by Quarkus, because after doing Quarkus, having to do JavaScript and save and refresh, Node.js was so slow. Quarkus is so much faster, which means that we have this amazing iterative feedback loop provided by the fast startup and restart of our Quarkus application. Okay, cool, isn't it? And I could be showing you a lot of other stuff, but what I want to share with you, of course, is how to deploy this particular application to my OpenShift cluster running on Azure. And remember, OpenShift is Kubernetes. OpenShift is the enterprise distribution of Kubernetes provided by Red Hat. And you know that since the beginning, if you go to the GitHub repo of Kubernetes, you can see that from the top 6 contributors of Kubernetes, 3 are Red Hat employees, and 2 of them are Google employees. That's how committed we are to the Kubernetes project, and we're doing a lot of things behind, and a lot of people love OpenShift because of the amazing developer features that we do. And if you tie these developer features with the Quarkus deployment features to Kubernetes, you'll be even more amazed. So we just developed this simple project. Let's try to deploy that to OpenShift. How can we do that? Let's do this the productive way, the easy way, the fast way, which is by adding a Quarkus extension. And you know, everything that you deploy to Kubernetes requires what? Requires a container. So we're going to need to generate a container image. Thanks to Quarkus, it's super easy, super fast. We also would need to create some YAML files, and nobody should be editing YAML files by hand. A machine should be doing that for us, because you know, YAML has a lot of like a significant white space, and you don't want to mess your YAML file just because you had like a wrong annotation. Let a machine generate that for you. Let some software generate correctly for you. So what we're going to do, we're going to try to add some extensions. So I want to create a container image. If you want to create a container image using Quarkus, you can pick between the Docker container image extension, or you can use the Jib one. It doesn't matter. Quarkus is going to generate optimized and secure images for you with both options, just for the sake of being like common, because I know most of people know Docker, but Jib works very well, maybe even better. I'm going to use the Docker extension here to generate a Docker image for me locally. I'm also going to use the Kubernetes extension. So the Kubernetes extension will allow me to generate my Kubernetes YAML files automatically for me. And if you ever played with Kubernetes before, you know that you need to be a good citizen in a Kubernetes environment. Your application might need to create your health checks, which means you need to provide your liveness and readiness probes. Luckily for us, we don't have to do anything because Quarkus can configure everything for us, the code, the application, and the YAML file. So I'm just going to add another extension called health, small right health, and that's it. Let's keep it simple. I'm going to add only these 3 small extensions, and you can see that the Quarkus extension for VS Code is just invoking Maven, and you can see here by the emojis that are green that everything went well. What else can we do? Let me switch back here to my terminal. I'm just going to briefly stop Quarkus in development mode. I know you love it, I love it too, but we need to deploy this to production. So if I just run a package here, Quarkus is going to try to generate the image using some defaults. But since I want to publish this to another repository on the internet, I would have to go back here to my application and configure my application properties file. So there are some properties that I would need to provide. For example, I would need to say to Quarkus and container image dot. First, I need to say that the group ID that I want to publish is Yanaga, because that's the name of my group repository in my container registry. My Quarkus, if I type it correctly, container image dot registry. So I can deploy to any Docker registry, any container registry available. I will deploy it to key.io. We pronounce key, but you can say quay, doesn't matter, as long as you use it. And what else? I want to also container image dot name. The name of the image is going to be Spark Joy, because that's all that we're doing today. We're sparking joy with Quarkus, Azure, VS Code, and Red Hat OpenShift. Oh, what else? I think it's enough for us. I just configured these properties. It's enough for me to build an image and publish to my container registry. So what can we do? We just have to run a Maven build. So I'm going to do a Maven. Let's clean just to make sure. I'm going to package. I'm going to skip the test. Sorry, don't do this at home. But Quarkus generates automatically an integration test. And since I changed the hello string, is not hello, it's hola. Now the test would fail. And I can add some parameters. I could have added them to the application properties file, but I want to configure when I want to build the container image and when I want to push it. So I'm just going to type these properties, container image dot build equals to true, and true if I type correctly again. Quarkus container image dot push equals to true. So with this command line, I want to build an image and I want to push it to my registry. So let's run it, and of course everything takes longer when you're watching it, when you're doing some live streaming, and I'm trying to just talk over what is happening. But you can see, if you ever create a Docker container, you can see that yes, Quarkus is already sending the Docker commands here on the logs, and you can see the from is copying, is sending the arguments, and yes, already pushed. So we built our Java project. We create a container, we push it to our registry in just 22 seconds. And if we inspect our target folder here, you'll be able to see that we also have now a Kubernetes folder. Let's see the contents of this particular Kubernetes folder. I have a Kubernetes YAML and a Kubernetes JSON file. It's a matter of taste, but let's try to see what's the content of this Kubernetes YAML file. When we do, you can see that Quarkus already generated for us. Here I have a service, which we'll be able to later to expose our service, and we have a deployment, Spark Joy. And let me scroll here. Remember that we added the Alpha extension. You can see here on my screen that Quarkus already added the liveness probes of my application. And Quarkus also automatically created the liveness probe. And here in the bottom, you can see that Quarkus already created also the readiness probe. And of course, we could add some custom liveness and readiness probe. Just in case I added a JDBC database driver, Quarkus would add the readiness probes to my database connection. So a lot of things are automated for you, so you can have the best of all the worlds if using Quarkus when running your application on top of Kubernetes, and in particular, even better, OpenShift. Okay, and that's it. That's all we need to do to deploy to our Kubernetes and OpenShift cluster running on Azure. So first, let me see if I'm authenticated. Yes, OC is the command line for OpenShift, OpenShift client, and it's a superset of the Kubernetes client. But since I'm logged in, I can use the standard kubectl command line. So if I want to deploy this application to my Azure OpenShift service, let's create a new namespace, new project, JDConf. Already exists, already created beforehand. So we just have to apply this one. Apply -f target Kubernetes YAML file. So yes, service created, deployment created. So if I switch back here to my browser And if I go to my OpenShift cluster, you can see this beautiful console showing you a lot of stuff. Let's go here on the left side of the screen, switch to deployments, and you can see that my deployment called SparkJoy is already running. If I click it here, you can see that I have one pod and it's already working too. If I can scale it up, for example, I can ask, well, let me add one more pod. Let me add a second, a third. I can also configure a lot of different stuff, but we don't have time for that today. Let's keep it one instance. It's still scaling up. And when this pod is particularly ready, you see it will be all dark blue. So container was created. It's running, but it's not ready yet. When it's running, everything will be blue. Okay, so I have 2 instances of my pod particular running. Awesome. Okay, let's scale it down. Try to save some resources on this Kubernetes cluster, and I'll try to use another feature here, which is if I get kubectl get services, I have a SparkJoy service. The easiest way for you to expose an internal Kubernetes service to outside with OpenShift is to use an OpenShift root. So for me to expose this service, I just type expose service SparkJoy, and I can now kubectl get root. You can see that I have this particular endpoint. And if I go back here to my browser and try to access that, you can see that yes, my new cloud native application is ready. But if I go to hello /spark rest easy /hello, yes, it is returning hola. You can see that my application is deployed successfully on top of OpenShift. It was seamless, was super easy, super fast, and it's already there. What else can we do to provide for you to run your applications on top of Kubernetes and OpenShift? Did you ever wonder, well, I have a lot of dependencies running already on top of Kubernetes, and maybe I want to develop my application locally, but I want to run my application and use the Azure services that are available inside my Kubernetes cluster. So I don't want to spin up a Kubernetes cluster and OpenShift cluster on my machine because maybe I don't have enough RAM and there are a lot of external dependencies, databases, message services that I don't want to be running locally because it consumes a lot of resources. So maybe it's a nice approach if I could, well, maybe just wondering if I could use this amazing development feature of Quarkus where I just save and everything is automatically there, but can I do that remotely inside my Kubernetes OpenShift cluster? Luckily for us, we can. Let's try to use the remote development mode inside the Kubernetes cluster using Quarkus. For this to happen, what do we have to do? We have to go back here to my IDE and type some additional properties. These additional properties are, first, I'm going to say package.type instead of jar. I'm going to use a mutable jar, which will allow Quarkus to update our jar remotely and dynamically. And we also have to say Quarkus live reload feature. The password is going to be SparkJoy because you don't want anybody messing with your application inside your cluster. So yeah, you should pick a better password. And we just need to tell Quarkus, well, on your Kubernetes and environments, we need to create a new environment variable called Quarkus launch dev mode, and it needs to be equals to true. So your remote Quarkus application will know that it will need to listen for changes provided by my local machine and update this application dynamically inside my Kubernetes cluster. And I think I did everything correctly. I just type it here, and to make it work, we just need to go back here to my terminal and try to rebuild this particular project. So let me get it here from the history because I don't want to waste your time. And npm clip package skip the task, container image build true, and container image push equals to true. Let's hit enter. This time maybe it will be faster because some of the layers are already cached. So it'll be, again, a seamless experience. So yes, we are already building, it's pushing. Oh, it's pretty fast, you can check that. And you can tell that it's live, it's not recorded, so I'm not speeding up anything. And again, in 20 seconds, my image is already there. we had some changes in the Kubernetes YAML file. So all we have to do is to apply those changes in the Kubernetes YAML file again. So that's what I'm going to do. kubectl apply -f target kubernetes.yaml. The service was already created, the deployment was already created, but now it was updated with that particular environment variable. So if I get kubectl get pods, yes, my application is already running. Let's see if it's really running. I'm going to switch back here and I'm going to refresh, running on the browser. Yes, it's still running Hola. Well, nothing new, correct? Well, that's where the magic happens. I'm going to go back here to my terminal and I'm going to type the magic string, mvn Quarkus remote dash dev the Quarkus live reload URL, and I'm going to point to my application running on Azure Red Hat OpenShift. So let's go back here to my browser. I'm going to get this particular endpoint without the REST easy hello, just the HTTP part, just the domain name. I'm going to go back here to my terminal, copy this particular URL. You can see that it's running SparkJoy, JDConf, ARO app.io, and hit enter. It's executing a Maven build again, and it's going to connect to my application running remotely inside my OpenShift cluster. It might take some time. Again, it's running remotely. I'm on the US East Coast, and my cluster too. Yes, it's already connected. It was faster, much faster than expected. I was expecting some glitches because I'm live streaming, but yes, it's already connected. Let's go back here to my browser. It's still running Hola, correct? And what if I get in my local VS Code? Instead of Hola, let's try to please our friends that speak French. I'm going to add some bonjour. And bonjour, JDConf, j'aime, I hope I'm timing correctly, j'aime Quarkus et Azure Red Hat OpenShift. Okay, I've typed this. I'm going to save the file. I'm going to send a new request to my browser. And this is where the magic is happening. Quarkus detected, the Quarkus application running on Kubernetes detected that there was a change. They are connected through a tunnel. It asked my local machine, my local development machine, well, do you have any changes? Yes, we do. So we compiled the changes. We sent the changes over the network to my Kubernetes cluster, and I was able to update my application dynamically. How cool is that? I think it can't get much better than that. That's how amazing is your development, deploying, and updating your live coding experience when you're running Quarkus with VS Code and deploying to Azure Red Hat OpenShift. And that's what I had to share with you today. I know this was a very fast session, very quick paced session too. Quarkus has a lot more features that definitely you want to try. I would strongly recommend you to go to the Quarkus website, quarkus.io, because you'll be amazed by the experience. And if I had the chance to just like tease you, I hope I sparked joy with you today, and I hope I convinced you that Quarkus is worth a try, and you should really try to use VS Code with the proper extensions, trying to deploy that on Azure and of course on top of Red Hat OpenShift service.
All right, thank you so much, Edson. Appreciate that. That was really cool. I played with Quarkus already, and I love it. I love it so much. And now that you guys put together a VS Code extension, you're really pushing me to try again the latest versions. That's awesome. I got a question for you. Where is the meme from Mary Kondo in your slide deck?
Oh, yes, sorry. I had to cut it off because I thought that I wouldn't have time to explain. But he got the point, he or she, I don't know. And because SparkJoy, I stole from Mary Kondo, but she's a Japanese lady. Well, I'm a Japanese Brazilian. I thought I could, but Quarkus is all around. Well, why did I take this SparkJoy? Because there are some things in your Java life like waiting forever for deploy, redeploy, start, stop, and consuming a lot of memory. These things doesn't spark joy. You just think and leave behind. And you only keep in your life things that spark joy, and Quarkus is one of them.
Awesome. Let us bring Deshaun, the next speaker. Where are you, buddy? Hey.
Hello.
Hello. I see you already have your T-shirt from Redis Labs. What's going on, man?
I got it, man. I've been here 11 days. It's 11 days. Like, you should have a T-shirt.
It's 11 days,
right? 11 days.
It's amazing. It's 11 days. You are already speaking at a conference on behalf of Redis Labs. Congratulations, first of all.
Thank you very much.
I see you have the T-shirt. You have the background Redis Labs on your laptop.
Oh, yeah. Wait, hold on. Thirsty.
I'll use the same excuse.
I guess I work for Guinness then, because that's all I have now.
You have a better beverage.
Yeah. Well, it's coffee actually. It's a coffee mug from Guinness. Though the drink kind of looks the same. And you even have like a red headset. It's like
I switched it all up. I'm waiting for my chair.
Oh man, where's James? James, you're gonna love this. Gotta give this guy a chair. All right, Edson. I do believe that there is some Redis integration with Quarkus already, right? Is that something that is possible?
Yes. Well, Quarkus if you're running on top of OpenJDK JVM mode, Quarkus will run with anything. I'm not sure. I have to check if we have a proper Redis extension that will allow Quarkus to run on native mode using GraalVM with Redis. But if we don't have, well, now that's opportunity. Maybe people from Redis could
PR's welcome.
Help.
Is that what I heard? PR's welcome.
And,
yeah.
Awesome. I guess, Deshaun, you're going to be talking about Quarkus after you talk about Spring Boot in a feature conference.
Yes. Deal. Edson, that was amazing. I just have to say, this is the first time that I actually got to see you, and I feel like I was kind of like next to you, sort of. But you did amazing. So you have at least one new follower today.
Thank you very much. Yeah, I'm pretty sure you'll be amazing too. Everybody's eager to know more about Redis.
Oh, you too. Stop. Come on. All right. Edson, thank you so much. You have a wonderful week, man.
Thank you.
We'll see you later. Bye now. All right. Deshaun, it's over to you, man. Last session of the day. After that, we're going to have an AMA, and I hope you can stick with us to send some questions for our Java team. But for now, let's talk about Spring. What's up with that?
Azure,
welcome to the show.
Spring, and Cloud. All of them. The whole
awesome.
Kit and caboodle. Let's see what we can do.
All right, talk to you later.
All right. Hi, my name is Deshaun. I've been doing Java for 20-ish years. I think it was around 1996 that I took it for a spin. I've got 4 kids. I live in Kansas City, Missouri, and if you joined us earlier, this is my 11th day as a partner solution architect with Redis Labs. I've got a certificate, and you can find me on the interwebs, at Deshaun. I also have Deshaun.com since 1996. I've been doing this stuff. Azure Spring Cloud is it's my new shiny thing. It's my new favorite toy. It's a managed platform that kind of takes care of all the stuff that I don't want to. I've been spending a lot of time on this architecture side of things, and I kind of like to just create code, get things out the door. For every one of those side project domains that I've got, youmakemenuts.com, I also have a Spring Boot project that I started at start.spring.io, and it's got a project there as well. I like to push out code. And this managed platform actually does some really cool things. I've dealt with the toil of having to build my own containers and having to patch my own containers. And I didn't like it. One of the things that I really like about this service is it kind of takes care of that for me. And it's got some really cool magic in how it can deliver those containers, those provided containers, quickly. It uses Azure Container Registry under the hood, but it's also got the Spring Cloud components that I've grown to love over the last 5 or 6 years, or maybe it's even 7 years now. But the cool thing about this service is actually supported by both Microsoft Azure and VMware. I use Jupyter Notebooks, and this is actually a Jupyter Notebook. This is how I'm presenting my slides. One of the things that I started to do, the original plan for this talk was kind of to show, hey, I'm MVP, I'm doing this thing, it works on my laptop, and then I'm going to take it to prod, and then I'm going to fight the scale problem. But I'm starting this new job, and part of this new job is kind of like I'm drinking from the fire hose. I got to learn. And one of the things, having adopted these Jupyter Notebooks, is I'm keeping track of what I've done. Like, what does it take to go from 0 on my laptop to having something running in the cloud? And this is kind of the journey. So part of being able to run these notebooks is I can actually execute code in the middle of my slide. So if you noticed a little number here jumped up each time I execute it. I kept track. That brew taps.txt, that's keeping track of the stuff that I'm installing. And I don't have to execute them, but it's just examples of I'm keeping track of everything I've done over 11 days. I got it all. I installed pip. Jupyter runs on Python, so I got some things I needed to install in order to get that working. I'm a big fan of SDK, man. And what this allows me to do is kind of jump back and forth between different versions. Maybe you still have apps that are on Java 8. Maybe you're using the adopt OpenJDK locally, but when you're pushing to Azure Spring Cloud, you might want to use the Azure version, since that's what they provide. One of the other cool things that I noticed was this plethora of reference architectures. I had no idea that this existed until just a few days ago. And I'm going to use this as kind of a reference. I'm not going to deal with a CDN right now, but I did. I created a simple app. That app's going to talk to a backend service, and I can also gather some metrics out of that app. I'm getting the information I need. But I just want to point this out. I always hear about reference architectures, and I've always actually kind of looked and hoped for something that I didn't have to kind of search through GitHub. This is just a really neat reference that I wanted to point out. So I went to start.spring.io. I hope you've seen that by now. I'll jump to it, and I made a simple app. Right, I can give my app a name. I can choose some dependencies that I want to deploy, and it'll actually spit out an application for me. I can generate it. I get a zip file that I can install on my machine. Start.spring.io. We'll call that my MVP, as that's how I started this. But I'm going to jump into that project. I'm going to do it all from my demo. So it's, hey, and you can see that I had that SDK man installed, and it says, hey, this is the version of the JDK that you're going to use. So now that I have that installed, I can actually build my project, and I will show you what I've done. Again, it's just a simple Spring Boot app, not as glamorous as what Edson just showed, but it does bring me joy. I'm new, and what this app is doing is it's actually kind of keeping track of, hey, how many people, if you're old and you've had domains since the 90s, you remember back in the day we had that page viewed number, and that was kind of like it's kind of like uptime at the same time. That page views, how many people have come to visit your website? And that's what I was trying to do here. So I'm just starting my app. I'll do that. Run it. Run it. And then I'm going to make sure, oh, I failed. Let's see what's going on. We'll try it over here. My app is running, or it's building, right? If it's building, it works. And what I'm going to do now is I'm going to go ahead and start it using the Spring Boot plugin. W. And I'm going to go over here and run this again. I have an instance that's up and running. Oh, this failed. Oh, it's because there's something that's already running. That's what's going on. I don't know where that is. I still have the 11-day jitters. Seven 532. Okay. Try that again. But again, all this app is trying to do is capture a request and throw it into a database. It uses a filter to capture that request. It's grabbing the information from the request, creating a page view, and saving it into a repository. I'm implementing it so it's only on the main page. I use a URL pattern, and that pattern says I don't want it to trigger for every CSS file, every JavaScript file. So it's only for the root of that page. And now, hopefully this will work. Yay. 1, 2, 3. I ran my request 3 times, and I can do that over here as well. Localhost 8080. Hey, and it's 4. All it's doing is it's that page view. That's it. But that's enough. That's enough to bring me joy. That's all I wanted to do. Simple app, store some data. And I can move on. Again, I'm using a Jupyter notebook, so I can kind of capture this. But guess what? It works on my laptop. And that's good, right? That's good enough for me. I didn't have to do a whole lot of stuff. I'll circle back. I'm actually using an H2 embedded database here so that I didn't have to stand up an instance. I actually went down the path of doing test containers for this, but I didn't think that I would have enough time to kind of explain that and do the bindings in the cloud. So I did a bunch of stuff before starting this demo. Like I said, I've got these notebooks. I'll show you what that looks like. So this is kind of what a notebook normally looks like. I created my environment variables. It says, hey, this is the stuff that I want to use. I can create my resource group, create my Spring Cloud instance, but I did a bunch of stuff before I started. And that was just like you would expect your platform to provide for you. The key here is I didn't have to create any tickets. The Azure CLI, which actually just got updated yesterday, or is in the Brew repository, I noticed got updated yesterday. I have this ability to go and stand up resources in the cloud agile. I can stand them up and I can shut them down. So not only do I have like a cloud initializing script, I've also got one that does my cleanup. So I have these steps. And it's not just go and build resources and build resources. If you haven't heard yet, there's this thing called cloud sprawl. It's where we get happy and, oh, it's so easy to stand up resources that we stand up resources and we kind of forget about them. Oh, it only costs a couple of pennies an hour, so we forget about them. But at scale, those pennies add up. And I want you to now start thinking about these pipelines, or these as pipelines, these Jupyter notebooks They are my pipelines. I don't need to have a Jenkins lab or Azure DevOps running on my desktop. I have these that I can iterate on. I can make changes in the middle and I can move forward. So I have the init scripts that kind of built everything, and then I also had the cleanup scripts. But those are the steps that I took before. My app works locally, so I'm ready to push to prod, right? YOLO. YOLO. So I've got my application. I built my application already, and this is what it looks like. All I'm doing from a command line is saying, hey, Spring, Azure Spring Cloud, I'd like to give you an instance of my application. So I'm going to jump over to the portal just to kind of give it a different view. I'll see if I can pump that font up a little bit. I'm in my Azure Spring Cloud. That Spring Cloud is a construct that I said is built up of that container registry, that Kubernetes cluster, the build service, and it's all in a nice, pretty box. I've got 3 applications deployed. I've got these applications are being bound to different services on the back end, but the one we just deployed didn't have any services bound to it yet. I can go in and I can look. There's no services. I'm still running in memory. But I also have more details. I can go back and I can take a peek. How is that application doing? I can look all my metrics because it is Spring Boot. Because I did include the actuator in my application. All those metrics, all the things that Spring is providing out of the box are being consumed out of the box by Azure Spring Cloud and the metrics wrapped around it. I'm using the diagnostic settings. So there's a nice tutorial online that you can go and capture all of that information. I will share my notebooks and the code repository, as well as the slides on GitHub after. So I've got an application. The nice thing that I like about the Azure CLI is all of the feedback that I get. The CLI, it seems very intuitive. I expect things. There's kind of a consistency across the different components. Azure Spring Cloud itself is actually a extension, and so is the application insights at the moment. So when you do install the Azure CLI, you do have to install 2 extensions in order to follow this demo. The other piece that we get, I showed you the metrics in the portal, but you also have that same visibility from inside the CLI. So this is where I'm happy. I'm in a good spot. Hey, I just pushed my app to production, but now it's there. I think I can grab that URL, and if you want to follow along, we can all go see it. Oh, here it is. Hey, there's 12. The first time that I experienced this, hey, I did it. I pushed an app, and now it's there. It's there for you. It's there for the world. The first time that I experienced that power of the platform, it changed my life. Right? It was a big deal. I remember looking around, everybody in the workshop saying, "Do you understand what just happened?" Right? In that workshop, we were kind of going through a simple demo like this, and I didn't feel like I wanted to do just the hello world. I was working on an application, just like you are. You're probably watching me on the side and working on your application. What I want you to do is think about your application. What would it take to get your application to the world right now? How many tickets would you have to create? How many resources do you not know? How would the firewalls work? Think about what that looks like. And that's what brings me joy. Edson, that's what sparks me. That's what sparks my joy. That's what sparks joy for me. My app is in production. So I'm going to circle back. Like I said, we have 3 apps. I've got one bound to Redis, one bound to Cosmos. I'm going to show you quick what that looks like. The idea, just like any major cloud, it's easy to go in and create those services. What I like about what I've seen so far in Azure's services is the tight integration. So right now we have this really tight integration with the MySQL database, the Cosmos DB, and Redis. Ah, surprise, that's really cool for me. And I want to show what that looks like in my init, where I create those services on the back end. I'm binding. Here it is. Like I said, all the configurations are there. One of the things I really like is I have the ability to change the small constructs on just about every service. And that's a real, yeah, it's a pleasure to use the API. But I created a config server as well. So if you're familiar with the 15-factor applications, we have this concept of, hey, I don't want to have my configurations stored in my code. I want my code to understand its environment and pull those configurations from a trusted source, a remote source, if you will. So I do have this backed by a remote service or by configs, and it's just a GitHub repository. Each one of these applications has their own configs. So if I'm connecting to Cosmos, maybe I don't want to install the H2 drivers. Maybe I don't want to have the Redis store yet. So these different applications are configured with different properties. And those properties get pulled in automatically by the platform. The other part of being on the platform is the registry, the discovery. So you'll notice that each one of these applications is actually registered with the platform. They are using that Eureka client to register themselves with the platform. And that makes it so they can discover each other. Going back. So one of the other cool things, hey, I handed the platform my jar file, just like we saw it's in do. Hey, I want to scale that thing up. I want my app to be bigger. I want to handle more. It's a pretty easy command. I'll scoot back over to the portal and I can see that command. I'm scaling up, which is cool. The very, very interesting piece about the Azure Spring Cloud is I saw that the maximum number of instances per Spring Cloud instance is 500. So I can spin this app up to 500 instances is the cap. So you imagine that across all of the different regions that are provided by Azure, and that gets to be a pretty big number. And the magic of Tanzu Build Service is that I can do a quick push. I can change that one layer of that cloud native build pack, and it gets distributed across the globe. So not only I don't have to manage the patching of the container, I don't have to manage those CVEs and rebuilding all the time. The platform is taking care of a lot of that for me. Big benefits so that I can focus on my code and my page views. Now, this is an H2 instance. It's in memory. This hasn't scaled up yet. There we go. Enjoy. There we go. Different instances. Magical. Different instances have different numbers because they're not synced together. So now what I want to do is bind to a Redis instance. I can see that my application Oh, does not have a binding. So let me go bind that. I'm going to go over to my init. I'm going to bind my application. Oops. Have those properties in line, and that'll come up shortly. But I can go take a look at my services. I created a small Redis instance. Now, the other cool thing here is I'm coming at a really interesting time. We are in this process of distributing Azure Redis Enterprise. This is kind of exciting for us, where we can create these Redis instances with active-active, with the multi-region setup. That is going to be in public preview within a few days. So you need to stay tuned. While that's scaling, I'll keep on going. After we scale up, we scale down. One of the nice things that I like to do, one of the nice things this allows me to do, is scale up and scale down. If you've ever had a VM with a ticket that takes 5 days, sometimes you want to hold on to that. But when you can scale up your services, your instances, and then scale them right back down, it's not such a big deal. Like I said, I can go and clean up after myself. You know, I can keep those pennies in line. And that's important. It's important to not exceed your budget. So while that's still running, I'm just kind of walk through, hey, we're deploying, we're having issues, but I can redeploy and keep on going. I don't have to wait. I'm not blocked. Again, I have access to my logs. I have a platform, and everything's good. And I'm running out of time, so I'll wrap it up. Binding your applications in Azure Spring Cloud is pretty easy. Having a platform to use is pretty exciting. It brings me joy. If you haven't had a chance yet, I highly recommend that you go take it for a spin. I think if you're lucky, you can, first-time users get a bucket of money to spend. I think you get 30 days to spend, some number. So you should go take a look. Azure Spring Cloud on Azure. It's the bee's knees. That's all I've got. I will share my URLs. I'll go back here, and I will put everything up here after.
All right, that's it, Deshaun. Thank you so much.
Drew,
can
thank
bring
you.
Can we? Hey, Cameron, can we bring his screen, please? So GitHub/Deshaun-JDConf-2020. So you can get all the resources from this organization. It's funny, you created an organization just for the conference. That's awesome.
I did, because typically I'm kind of doing the last minute, and I want you to get all the goodness. And it's nice to kind of have that snapshot, like, hey, here's what it was. And like I said, I'm a big fan of the Jupyter notebooks. I like to put those slides up there, and I'll just dump everything in there, and that's just one stop. You don't have to search.
That's sweet. And it's also accessible.
Accessible, right? Yes.
As we learned.
Yeah, you notice I took out all my pictures, but what I didn't see was the way to turn on the captioning. I didn't know how to do that.
This video will be available on YouTube, And on YouTube, it has a live caption feature. So everybody who's watching and they want to see the caption or they want to enable text to speech, YouTube supports that. So don't worry, it's covered.
Wonderful.
All right, so I would like to invite our speakers for the AMA. So I'm gonna invite one by one, and everyone will say hi to you, Deshaun. And after I have everyone here, then I'll let you go. So let's start by inviting Kirk Pepperdine, who helped organize this conference. Hello, Kirk.
Hey, Bruno. How are you doing? Hi, Deshaun.
Hello, hello.
Long time no see.
All right. So to everyone watching, Kirk helped us put this conference together. He invited his friends on the Java community who were very happy to participate. Kirk has been helping me behind the scenes a lot over our chat here. Hey, here's what's going on. Here's like how much time we have left and all that sort of things with the production team as well. And Kirk, you're going to stay here for our AMA. So let's jump to our next guest. Let's go with George Adams, the gorgeous British person, George Adams.
Good evening, good afternoon, good morning, kind sir.
All right, so we got George here. George, did you like Deshaun's presentation? Was it cool? Azure Spring Cloud and all that good stuff?
I must admit, I only caught the last 15 minutes, so I need to do my homework and watch it. But it's really awesome. You put it all into a GitHub org so that any of us can just go and play with that. It looks like you've been doing some really cool work there. So thanks.
Absolutely.
All right. So it's interesting that. For folks that also could only jump in the last 15 minutes, don't worry. Deshaun's presentation will be available on YouTube for on demand, so you can watch later. Or Deshaun, you can watch your session later if you want. It's up to you.
My mom and dad are going to be looking for it. That's all I know.
Your mom and dad.
Mom
Hey,
and dad.
the more viewers we have on YouTube, the better. All right, our next guest, Bernard from the OpenJDK on ARM. Bernard,
Hey,
welcome.
how's it going?
Oh, well, you're all good, man. Can I run Spring Boot applications now on Windows on ARM? Is that right?
Yes, you can. It's amazing.
All right.
We just tried it out on Tuesday for the demo, and it actually worked. We were quite surprised, to be honest. Yeah.
All right.
It was actually the very first time for me that I was running Spring Boot, so it was amazing.
Oh, sweet.
Yeah.
You did a Java minus jar, and everything worked nicely.
Yeah, it was like Maven,
Awesome.
Spring something.
Amazing. So let's bring her, the lady, the amazing Monica. Where are you, Monica? Hello. I see you kept your background. That's nice. Let's shine this conference.
That's exactly.
Welcome. Our next guest for the AMA will be Charlie. You, Charlie.
Hey guys.
All right, Charlie, you presented at FOSDEM earlier this year. You talked about stack allocation. Can I stack allocate my Spring Boot apps? Is that how it works?
You could Spring Boot parts of it. Stack allocate parts of it, I think, but we'll see. That's still a work in progress feature, so we'll see how things turn out in the long term.
Okay, awesome. And I think we are missing one person or two. Let's go with Martin. Are you there, Martin?
Yeah, hi everyone. How are you going?
We are all good. Welcome to the show. Everybody can say hi to Martin at the same time, so we see hands all at the same time instead of
Great presentation, Deshaun, by the way.
Thank you.
All right. And finally, our last guest, our surprise, we have somebody breaking into JDConf. The person's name is Scott Hunter. Oh my God. We have a C#.NET person here. What's happening?
I was a Java person before I was a C# person.
Were we all?
That's right. We'll get you back to the side of light, Scott. Don't you worry.
All right. So for folks who don't know, Scott Hunter is the PM director for .NET and also now Java here at Microsoft, where I'm working at. Myself enjoy to work with Scott. Java and .NET have so many similarities. Some people actually ask, is Microsoft going to run C# on Java? Is Microsoft going to run Java on C#? It's not what we are doing. No, folks. Those are great technologies for their own ecosystems and communities, and we're going to support them all. In fact, Sean, I don't know if you heard, but you can now run .NET applications on Azure Spring Cloud. Have you heard about that?
I absolutely have. My good friend Robert Suchia here, as soon as I heard it, I was like, hey, Robert, like it brings me joy. We like doing that kind of back and forth between the .NET and the Java and the Spring, and it's been fun. So yeah, I am excited about it. I'm a big Steel Toe fan.
And just to you're so Scott, you just jump in here. Like Deshaun, he's working for Redis Labs for 11 days, and he already has a T-shirt. 11 days. He has a T-shirt, a background wallpaper on his laptop, a water bottle, and his headphone matches the logo. All that in 11 days.
Such an I'm all in.
All in. Well done, man. All right, I'll let you go, Deshaun. But before you go,
I got a question. I'm saying I'm here. I want to get my question in.
Yes, please bring it on.
I got a survey, and the survey got me a little excited. It was the Java survey. I think it was associated with the registrations, and some of the questions on the survey really piqued my interest. I've got maybe this is like a guess of what's coming down the pipe with Microsoft, and 2 questions: Cloud Gateway and Spring Cloud Data Flow. What can you tell me? Because I'm excited. Goosebumps.
That's a very, very powerful, strong question. I gotta say, I have to think about an answer before I give it to you. So, without knowing that many details of the survey that you saw, I will say that the survey's intention is really to find out users' interest in those technologies, so we can find out what else to develop on our roadmap for our services and products, right? So Cloud Gateway has support for any kind of workload, but if we can make the integration easier, especially for Java apps and Azure Spring Cloud, the better. So we are trying to find developers or .NET apps, right? If you're running on Azure Spring Cloud, yeah, absolutely. So we are trying to find out the interest so we can prioritize our roadmap. That's what the survey is about, and getting feedback on what people want and when they want. So I hope that answers the question.
Yeah. So if I send the survey in 10 times, is it going to count 10 times? Just curious.
I think we have. I think we have a. We have a good. So we have a good tool that can filter duplicates. It's called Microsoft Excel. We put everything on Excel and just filter the duplicates. It's easy. It's easy. Perfect. So it will probably just count as 1. So I'll let you go. Thank you so much for sticking with us. Appreciate the content, appreciate the session, and I look forward to see more stuff from Redis Labs, working with Microsoft and Java community and the .NET community. Appreciate it.
Thank you.
Thank you.
All right, folks. So I guess we have a nice AMA here, and I cannot start in a different way other than asking Scott a question that he got on Twitter. And Scott, you gave an excellent answer. I'm looking at the tweet here. Where is it now?
I can tell you what the tweet
what Java? Yeah. So, what Java thing that you would like to come in .NET, and how this Java team can help the .NET team bring that to life?
Yeah, so the on that question, the biggest thing that comes to mind to me was, what Java feature would we want to bring to .NET? And .NET has always tried to be kind of like automatic, which means no matter if you're running a IoT workload that uses very little CPU, or you're running some huge application that uses, has millions of users on the web hitting it, we try to just naturally make our garbage collector in tech just dynamically adjust to whatever you're doing. And I was talking to part of my team one day. We were running some gRPC benchmarks, and the .NET tech was just below Rust. And then I heard that, and Java wasn't doing well in this benchmark. And then I heard that Bruno popped in and took the Java number and made it be the best number. And he did that by turning a bunch of dials on Java. And so to me, I would love to bring the best of the dials that exist in Java to .NET, so our customers can better tune .NET to the particular workload that they're using. And I happen to know from some of my friends that work at other companies like Amazon and stuff that they use Java in many places where they are tuning Java explicitly for particular workloads, whether it's changing the garbage collector, changing the memory footprints and the way it deals with memory. And so I think that's an example of feedback you could give the .NET team to help them have a better product in the future.
So I when I was playing with those knobs and tweaking the JVM, all I could think of, I have no experience with this thing, and I'm just throwing these parameters to the JVM and hoping for the best. So I'd love to hear from Monica. She's laughing hard. And Kirk, you have some experience with that, I guess. What do you guys think about how tuning the JVM? How does that work? Let's hear a little bit from Monica.
Oh, it's black magic. No, I mean the JVM offers so many blogs that you can look at, and it's easier to let the log speak to you. So I don't really need to know your application. If I can see the GC log over a period of time, I can detect the patterns, and I can understand if there are any pain points that are visible with respect to the GC, for example, I can understand that. And then I can ask you to enable a further logs so that I can look at those, and then eventually we'll get to the bottom of it. Your system has lots of information that it can provide as well, so we can get other stats from the system itself all the way down to the hardware and the various these are called hardware counters, and Kirk can definitely help us more here because that's what Illuminate that's where Illuminate actually shines. So over to you, Kirk.
Oh, right. I think you just about said it all. I don't know if there's much else to add to that, except for I thought we were trying to get the JVM more auto-tunable so you didn't have to play as much with the knobs. So I think we're looking towards .NET for that help.
Well, I think when you talk about logs and data that the JVM produces, folks ask what differentiates the Java runtime against other runtimes, and as Scott said, these are some of the things that the JVM has that he would love to see on .NET. When we see the recent advancements in the JVM, we hear about Java Flat Recorder and event streaming. I think that's an interesting topic. I'd like to hear more about that. Let's go with Martin. What do you know about JFR events?
Yeah, so JDK Flight Recorder, or Java Flight Recorder, as folks may have heard about it, it used to be a commercial technology that was only shipped with Oracle's Java. They very kindly donated it to the Open JDK project, which is the open source project behind Java itself. And recently, with a little bit of nudging from ourselves and a whole bunch of other vendors, we managed to get that into Java 8 as well. So it's an inbuilt telemetry system for the JVM, which is actually in there under the hood. You don't need to attach anything special to go get this telemetry data. You just switch Flight Recorder on. It can do so in a low impact manner, and it emits all sorts of events that you can request from it. What the CPU is doing, what your threads are doing, what the objects are doing, what the garbage collector is doing. And today there's a rich client called Java Mission Control that you can use to read all that information. And when you have experts like everyone on this thing, Charlie and Monica and Kirk, for example, they can read that information very quickly, get to the bottom, to the answer. So one of the things we're looking at here at Microsoft is how we can bring that capability to cloud scale, right? And so that's something we're looking at very closely here internally with our tooling group.
And speaking of cloud scale, Microsoft is investing in ARM-based chipsets And when you talk about data centers, we talk about energy consumption, and if there's any way that we can overnight just flip to ARM and spend less with energy, I think that should be like easy, right, Monica? That should be easy. No, like all the servers.
Absolutely. Yeah, I mean, there's a great term that we use a lot at Microsoft. It's called COGS, right? Cost of goods sold. And yeah, I mean, if you attended my talk yesterday, I gave an overview of where ARM started with respect to 64-bit and where it's today. And there are so many. It's moving towards. We know of ARM as a weaker model, so people are kind of thinking about, there may be synchronization overheads, but ARM is improving on all those. And I talked about ThunderX2 with 256 hardware threads. Oh my gosh, that's mind-boggling. So, and Bernard, do you want to? I know you're smiling because we were a part of enabling Java JVM to scale across these threads. And oh wow, I mean, the first time we saw all the cores fired and the hardware threads fired, we were like excited. We were celebrating. Virtual cheers to everybody. Do you want to add something, Bernard?
Yeah, I mean, I'm working with ARM64 devices since 4 years already, but I started with, mobile phones, which are okay performance-wise. But when I joined this team, I had access to a TX2 with like 128 cores. It's amazing. Like if you can build the JVM faster on the target machine than on your dev machine, it's amazing. It just takes like 2 minutes to build OpenJDK.
So if we can have all these capabilities and this power, I wonder, Charlie, how easy it is to add stack allocation support on ARM right into the chipset. Is that possible?
I don't think it would be super easy to add stack allocation to the chipset. I've had lots of colleagues in the past who worked on Java on the actual Java silicon and stuff. Not so sure that's something we want to talk about doing ever again. I think everyone's left that in the past. I do think there is lots of opportunity for less objects to be allocated on the heap in Java in particular. But there's a whole multitude of ways that can be done, and I really don't want to go down to having a chip do it for us.
But
I mean, what could go wrong? You just patch the chip later after it's shipped, right?
But Bruno, your question was on the right path, though. If you talk about stack allocation, actually, the escape analysis in general, it's all about allocating on into registers, right? You don't allocate on heap. Have the processor registers directly access that the data, and ARM provides that benefit too. ARM has a lot more number of registers available, processor registers available. So yeah, right. It does. Your question made perfect sense until you said on the chip, and I was like, that's fun.
I love that. I love that I turned like I don't know what I'm doing. Suddenly comes a nice question out.
Oh my God.
So I'd like to comment here because I mean we've been looking at all of the memory bandwidth issues and just about every application you can look at, and this is a chip level problem. So when you get it, it just kills the performance on everything evenly. So profilers don't even see it because it's just like an even sluggishness. You're stuck in the mud, and I don't know, like Monica, I don't really have experience with ARM yet. It's like, what's the memory bandwidth situation look like in that chipset?
That's an interesting question. So yeah, like Bernard mentioned, ThunderX2 has like 128 cores. So yeah, definitely memory bandwidth is a big consideration. There are some optimizations done. It's all about the memory channels and the data widths of these channels. So there's a lot of optimizations done in the design of these chipsets, and I encourage people to use to get more information out on the interwebs, because there's some details that maybe when we do experiments we can figure that out as well. But I cannot share more right now, but there are definitely, as you scale, you want to be able to scale the memory channels and the width of those buffers also matter a lot internally. So it's not just ARM; it's also done for Intel, for example. These interconnects are really optimized for to maximize the bandwidth.
And the interesting thing here is, Microsoft is doing this work for Windows on ARM, and I know, Scott, you and the .NET team, .NET Runtime team, are also working on bringing the full capabilities of .NET into ARM. Is there anything you want to add about ARM from the .NET space, how you guys are doing that? Because I think it's interesting because the efforts from a runtime developer perspective are quite similar.
Yeah, when it comes to ARM and .NET, we've actually had ARM Linux support for a long time now. So for about 4 or 5 years, ARM Windows support comes with .NET 5, which ships in a week or so, 2 weeks. The big challenge for us is not the actual runtime; it's getting some of the bigger workloads that run on top of it. So in the case of the .NET world, we have things like WinForms and WPF, which are the visualization stacks. And so there's a lot more work to get one of those things to move over, because those things have lots of native code inside of them as well. And so, getting the runtime to go is not that hard. One of the differences for us now is we are trying to performance benchmark the ARM tech the same way we do the Intel and AMD tech. So that's an area that you'll see more effort on us in the future. And I was going to say there was something I was talking to Martine about during this last conversation of things that maybe Java could steal from .NET. We just added in the .NET 5 wave stack alloc as a way of allocating memory inside of a function that is on the stack. So you can actually decide, hey, I don't want to go actually get on the heap because that's going to require a GC at some point. And so there's now a way that you can micro-optimize and actually put some stuff on the local stack. Buffers or whatnot will just go away, obviously, when the function.
That's an interesting topic. Charlie, you want to add something to that?
Yeah, in the past, I think for me, one of the things I investigated even probably before my Microsoft days was actually allowing people to via an annotation. At the time, we didn't have value annotations in Java, which they're there now. And I think with that, if you were going to allow a good way for a user to hint for something to happen, now I know there's all kinds of downsides to allowing the user to hint, but when they do know that something isn't going to be used and they could direct to say, just go do this object on the stack, I think you could have some pretty big wins. And in some small targeted workloads, with prototypes in the past, I was able to see ginormous wins, never GC because I was handling a transaction or something, a request, and I know that those 15 things are never going to survive. So I said stack allocate them, and it was enormously faster and no GC pressure. But those are the types of things that kind of have to feel out what the Java community wants in the future going forward, and then build on that with other community members and see where we want to kind of take that type of tech to.
In the case of .NET, some of these, where they came out of was when we first started building the newer .NET, which is .NET Core, and started really caring about performance, we did a bunch of nasty code tricks to make some of this stuff go fast. And so we've literally been trying to go and erase all the unsafe code that we wrote and try to make it something supported by the actual tech itself, so our team doesn't have to build, the tech's open source. I don't even want you to see what we did in 1.0 of .NET Core to make it go fast. We were doing, there's a feature in C# called unsafe.
Yeah, we have the same.
Yeah, welcome.
and so we literally tried to kill all unsafe, and that's why we've done it. And so it's actually been an output of us performance optimizing and taking the learnings from doing that from our own perf optimization to try to put it back to the tech.
Cool.
That's really classic.
I've never seen a managed runtime not need a backdoor like unsafe. There's always something that you want to do that requires unsafe, and it doesn't matter. It was the same in Smalltalk, right? It just goes all the way back.
Smalltalk. Martin, you had something to say?
No, it's really funny that the Java also has the very infamous unsafe class, which is derided and beloved in our ecosystem.
I just saw a JAP this week on the OpenJDK project. It's all about encapsulating all the internals of Java except unsafe and a few others. Like, okay, you can close everything except unsafe.
The cat very much got out of the bag on that one for the Java ecosystem.
Exactly.
Yeah.
And speaking of JABs and OpenJDK, I think George, you've been working with Adopt OpenJDK and building a community along with Martin and others on the LJC. What are some of the interesting things that have happened in OpenJDK and how the community have been collaborating with OpenJDK through the since the flip, I guess, from 8 to 11, and when things actually happen for the community?
Yeah, thanks, Bruno. So there's been a few kind of really interesting observations we've seen at Adopt OpenJDK. One of the things we're really relieved to finally see from our download statistics is that day by day now, Java 11 is getting more downloads than 8, which I'd like to think we all think is a huge success. If we can get people migrating off 8, then I'd argue that's a win. One of the other really exciting things is Adopt OpenJDK was one of the real drivers in getting a macOS notarized build of OpenJDK into the ecosystem. And it was great to see a community kind of take on that ownership and actually get that resolved rather than relying on an individual company to get those sort of patches prepared. And it really did unlock the door. And fortunately, everybody's been able to take those patches and provide their own notarized build of Java so that Java can still run on macOS, which would be a disaster if it couldn't, of course. And then I guess the other really exciting thing is the move to the Eclipse Foundation. So we mentioned it in the keynote yesterday, but it's super exciting to see us move away from the humble LJC into a more enterprise-ready software foundation. Hopefully it will allow us to spend more time on developer outreach, get to more conferences, put more time into code and making things continue. And hopefully we'll sort of exceed the 200 million downloads we hit last week and continue to go until we run out of digits.
I was a little bit shocked when I heard the new name of Adopt OpenJDK under the Eclipse Foundation. Is it Eclipse Adoptium?
Yeah, it is. We describe it as Marvel-esque. Unfortunately, a group of software developers are not very good at naming products, and unfortunately, that's what happened.
I was hoping that you guys would call like Eclipse Sunrise or something like that. I don't know.
Yeah, trademarks don't go down well. We tried all of those. Yeah, there's an even more exciting name.
Yeah, we probably spent half a day coming up with names and another 5 weeks looking at the legal implications of all of those names. And trust me, it's not something you ever wanted to go through.
You just bike shed for half a day on names? That's a record. Ask Scott. Scott has some history with naming things at Microsoft.
Yeah, I've what I've learned is all names suck. You can never win, and I've spent over 6 months in some cases on this stuff, and I know products in Microsoft that have spent over a year, primarily because if you want to do like imagine your PowerPoint or something like that, well, you have to make sure that name is not only valid in the United States but in Russia and the UK. That's the challenge you have. Is in many cases, big companies like Microsoft actually go and pay off various countries so they can actually use the same name all the way around the world. And so luckily, none of us on this call work on things that are that magnitude of like, OS level or Office level kind of stuff, because that's when the naming gets really, really hard to have a trademarkable name all the way around the world.
And there are some challenges as well when you name things and then they are translated to other languages and they don't mean what they should mean. It's like one of those challenges. Scott, I just want to pull you into one more thing. When was the last time you played with Java?
3 weeks ago.
Look at that. We're making headway, folks. We're making headway.
We are almost there. We are almost there. I hope it was a latest version of Java, not Java 1.5.
It was not. It was the latest version of Java, but I have Java on all my machines now, so I'm fully converted.
Awesome.
We'll see if we've got any job openings for you there, Scott, just in case you want to come across.
PRs are welcome, Scott. PRs are welcome. As long the methods don't start with an uppercase letter, we're all good.
I do think there are things that both .NET and Java can learn both ways from each other, and I hope that some of the OpenJDK investments that we Microsoft are going to do would make that open. I also want to be very careful. I don't want to cause any wars between the I think it's a different era than it was way back in the last time Microsoft was in the Java space. But in the .NET world, we try to learn from everybody, and I assume Java tries to learn from everybody. And I think there are ways that we can learn from each other as part of this process.
Yeah, that's exactly how we feel. At least we, as Java developers, when we look at C# and we think, oh, this is a great language feature. When will Brian Goetz? Hey, Brian, when are you gonna bring that Java language, the C# language feature into Java? Sometimes it takes a long time. Sometimes they actually implement. So it's good to see that all languages are benefiting from each other. I think eventually, I don't know, in 250 years from now, we're gonna have a single language to rule the world, and they combine everything in a single thing.
And it'll be a visual programming language, Bruno.
I was going to add that JVMLS for a couple of years, actually, we have the .NET team come in and give talks about CLR. This was before I joined Microsoft. That's when I met the .NET team, and we had dinner together, and we were bonding over I guess that was value types back then or something. So a couple of years ago, and since then we've been good friends. And again, this was before my time at Microsoft. So I was like, oh, wow, we have so much to learn from each other, So, yeah.
Yeah, that was right. They were in at QCon in San Francisco.
I invited them. Yeah, I invited them.
Yeah, that was well done.
And you
that
too.
That was a very interesting. They gave very interesting presentation about the guts, and we had a nice conversation afterwards because they were seeing pretty much the same problems we were in terms of how to manage memory and memory footprints.
Yeah, and exactly, and I was not surprised, but I was very happy actually, because I was the organizer, to see the AMA for .NET team to be such the room was packed, and yes, I mean, that was something that was, living in my bubble of Java to see that. I was like very, very, very happy. Yeah.
Very nice.
So I got a question for you all. The question is, how's life as a Java developer at Microsoft? That's a question I see a lot over of Twitter and Reddit. What is a Java engineering group? Let's start with that. What is a Java engineering group? Let's go with Martin. You lead the team. What is a Java engineering group?
That's a fantastic question. So interestingly, the Java engineering group doesn't actually have a lot of core Java engineers in it as such. Like, everyone's more than capable of writing Java, and we have in our tooling team in particular, they write Java every day. But we have a lot of VM engineers, so they actually spend a lot of their time in C++, C, and the beautiful language that is assembly. And so, when you do code reviews and things in our group, you're going to see assembly as much as you see anything else, apart from YAML, of course, which is Bruno's favorite language.
It's not me who's using Visual Studio as my ID. It's you guys.
So yeah, very quickly, so we obviously have VM engineering as a very strong cohort that we have in our group. We have performance analysis tooling, which Kirk pretty much heads. We have professional services, and of course we have our wonderful program management folks, which Bruno and George, they name things for us, if nothing else. But perhaps, yeah, let's go around. I'd love to hear. Now I get to hear what the experience is really like.
Yeah, so let's go, Bernard. When you thought about joining Microsoft to work with Java, for Java, as a Java C++ engineer, how was that?
I'm with Microsoft for 4 years already, and I was in the .NET team before. But I cannot write C# and I cannot write Java, so I cannot talk about anything like that. It's the wrong abstract layer for me.
As long as you can make the JVM run on ARM, I'm all good, man.
Exactly, and that's the exciting part for me. I believe ARM 64 is the future, and I'm glad that Microsoft is willing to invest in that. And I'm glad that I'm part of that, and it's fun for me.
Awesome. Charlie, you've been a member of the Java community for a long time. I think you came from IBM, is that right?
Yeah, I worked on J9 for basically my whole career until last year. So I've been at Microsoft for a year now. it's a completely different JVM, but it's all the same things. So it's great. I've been enjoying my time at Microsoft. It's another. I'm happy to see another large company get involved in the OpenJDK community and actually be putting investment into it, because I think that's very important. That's kind of like been always my view on OpenJDK from my early days at IBM. So I'm just happy to be part of that and happy to be part of Microsoft's effort into improving OpenJDK, because I think with the core team who we've put together here, along with the other groups that we can collaborate with, I think we can do some pretty good things.
Kirk, when you look at the state of Java performance and contributions from multiple companies into OpenJDK, do you see a future where the more contributions we have, the more magic OpenJDK will do, and we will not have to add 200 parameters to start a JVM? What are your thoughts?
Well, I mean, that's the hope, and there's some wonderful ideas coming from all kinds of different different companies now that have sometimes competing concerns. So that's probably why you're never going to get away with getting rid of all of the flags. But it's really kind of exciting, especially being here, because we have access to just about any amount of data that we want to drown in, and I think for performance tuning, like data is a key thing, and it's just that aspect of it is just absolutely wonderful. The opportunity to take some of our ideas about how we can make tooling smarter and just apply them across a wide range of workloads. The opportunity here is just pretty much non-existent in just about any other place. So it's just amazing.
And it's interesting, as we heard from Scott on the .NET, they try to make the runtime as adaptive as possible, where the JVM runtime always, like, it started a lot with, there are only knobs that you have to change, and except for the JET compiler, of course, it will optimize over time. But for most of the settings, you have to provide those inputs. So it almost feels like we're now turning the JVM, or helping build the JVM in a way that .NET runtime is kind of developed today, with a more adaptive way. I don't know. I'm not the expert here, so that's why I'm going to throw it out to you. Monica, you have experience with that. Bernard, you also have experience with the .NET runtime. Do we see the JVM runtime following some of the ideas of .NET runtime, or the other way around?
So my background has always been OpenJDK, or Sun JDK. So I wouldn't know much about the .NET runtime, except for recently we've been looking at managed runtime in general and trying to figure out workloads and patterns with respect to data centers and usage and everything. So I was working with this internal team. We have a couple of interns, and we were doing these comparisons. So I'm not surprised, but I find similarities more between these managed runtimes than when you compare them with the static compilers and the spec ints, the benchmarks and everything. So benchmarks themselves have evolved a lot thanks to the managed runtime. So now we can see not just the VM range, but also for, prior to that, we always talk about like memory bandwidth, and we will talk about the responsiveness. But now benchmarks are evolving into different combinations and different improvements. Startup is also a great consideration. I think .NET has one, and we are catching up, and Java is catching up. I don't know, Bernard, your experience matters here, so maybe chime in, please.
Yeah. I mean, I have no idea about garbage collectors, but on the JIT side, like Java has always been more advanced in terms of tiered compilation, and have like the interpreter, multiple compilers on top of it, and so forth. And since 2 years, I think, there are some efforts now in .NET Core to bring that also over into the .NET world. So they added tiered compilation, they added support for de-optimization and all that fun stuff. So they're learning from Java, actually. and that's pretty cool.
So when we talk about all these learning experience, George, how can developers leverage the Adopt OpenJDK project or Eclipse adoption now moving forward to engage with OpenJDK project in a more experimental way? I just want to try things.
Well, I think the main thing to say about that is obviously, rather than going off as an individual company or developer and trying to hack away at a single thing on their own, benefit from the fact that we've got all of these JVM companies together working in a single place, and let's use that as a way of collaborating. Let's not rewrite the wheel 10 times. If we've got a build script that works to build OpenJDK on any platform, let's use it. If we've got a build farm that's capable of putting PR testing through on any platform, let's use that. We have access to so much hardware that even about a year ago we would have dreamt of having. We have early access Mac stuff. We have access to a load of Windows on ARM, and even like IBM mainframes and stuff. So if we can benefit from that, I think that helps. And just take advantage of the code that's there and try and bring it in-house, and learn from the open source method and contribute everything we do internally back out to the community and let others benefit from it.
Awesome. All right. So we are at the top of the hour. I would like to thank all of you to participate in this AMA. For folks who are watching, check all these Twitter accounts that you see here. Just follow them. Charlie on his stack allocation expertise and JIT compilers. And Charlie, you know way more than just that. I'm just giving an examples. Monica, she's a GC expert and she's doing all this ARM development as well. Bernard, you are the best C++ developer I've known of in recent years, I guess.
I don't know any C++. That's amazing.
Oh, you are. Bernard, yes. The answer
I can
is
only
yes.
debug it. I can only debug it.
Hey, if you can...
Just 99% of the job when you're working C++.
I would like to thank George as well for his amazing work with Adopt OpenJDK and here at Microsoft helping us build binaries that we are testing internally. That's where our contributions to OpenJDK are validated. We have to build and test, right? So thanks for your support on that. And Kirk, thank you for your support with this conference. It could not be it could not have been any better without you. And Martin, your support and the support of the LGC as well along these years. You are an amazing person. So all of you, thank you so much for making this event a reality here at Microsoft. And to all the speakers, I just want to put here on my screen. So let's see if we can pull my screen here. So all these speakers that presented at JDConf, you go to this website and you're going to find everyone who presented. Thank you all so much for an amazing collaboration effort. All these companies, all these partners, all these friends in the Java community that we've made throughout the years. Thank you so much. So with that, I'd like to close and just saying this is the first JDConf. It will not be the last. We're going to be back next year. When? We don't know. Virtually? Possibly, but hopefully not. So thank you so much, everyone, and have a great week.
Thank you, Bruno.
Bruno. Thank you.
Yeah, thanks, Bruno.
This is a great conference. Thank you.